Hey, good evening, everybody. Welcome to Advanced Programming with Java here at Portland State University. I'm really excited to be back. I'm David Whitlock. I'm the professor for this course. Really excited that I got invited back to teach again. And I'm teaching in the winter too. So normally I teach in the summer. It's an 8-week course. We have an 11-week session this time, which I like. It allows us to cover a little bit of extra content. What the students have told me is that it doesn't seem as rushed as it does in the summer. So, hey, I know you have a lot of other courses that you can choose from. So thank you for choosing this one. I hope that you find it to be an overall enjoyable experience and that you learn a lot. Let's start tonight. So we've got a lot of things to cover tonight. Mainly, not only just getting an introduction to the course, it's sort of talking about the syllabus and all that sort of day one stuff. But we're also going to sort of get everybody started and see how to work with some of get your environment set up and start seeing some of the tools that we'll be using in this course. Let's see here. Let's dive into it. So I've got some, actually I've got some slides here. So hello everyone. Let's see if those of you in the classroom, I'll just try to make this so you can see everything. Oops, make this smaller. Come on, there we go. Good enough. Okay, go to see me. Turn Alex back on in a moment. So, hey everybody, welcome. So, I've got some stuff we're going to do tonight. So we'll introduce ourselves, myself and the graders. Then we're going to talk about the syllabus and what this course is all about, and some of the topics that we'll be learning about. And then, because I like to have both, like, you all talking with each other in addition to just listening to me talk, we'll go into breakout rooms and talk about our experiences learning remotely. We've been doing this for a while, but I think every time, we're still learning. I'm still learning how to most effectively deliver a course that has people here in the classroom and people who are at home or someplace else. Then we'll start using some Java. And so we'll create our first Java project. We'll see how that's done. Over the years, I've developed a GitHub repository that helps people get started with the course, and so that you can get to programming Java as quickly as possible, not have to, and with like the minimal amount of tool setup and configuration. So we'll see our first Java project. We'll learn about something called the Java Koans. That is a way to learn the Java programming language in very small bites. Along the way, we'll learn and start seeing test-driven development being applied, and we'll learn about it, and then we'll apply it together. So I just got to say in advance, tonight's going to be one of the longer lectures. We'll probably go until 9:30. Normally, I don't like to go that long. I can't stay up as late as I used to. The perils of age, and but tonight and probably next week will be kind of longer, and then we'll get into a more regular groove where we'll be hopefully done by 8:30 or 8:45. But we'll see. As we'll learn, we'll be doing some in-class activities, and if it's going well, let's stick with it. But hey, if it's when it's time to go, it's time to go. So. Who's everybody? First of all, it's me again. It's David Whitlock, and so I've been teaching this course since September 2000. It's been 22 years now. I know, right? They keep inviting me back, and they hired me when I was 14. I've been doing this for a while, and it's been for me. It's been very gratifying to be able to build and evolve a course over time as I've learned more as a software developer, as the field around me has changed and learned, and what I try to do is provide an experience for you all that is relevant, distinctive, so that you get to maybe see some stuff you don't in other courses, and get to experience some things that you probably haven't before, like pair programming, mob programming. So let's see here. So that's me. We're also joined by two graders this term, Lakshmi and Alex, both of whom have taken the course before, and now they're coming back to grade. And we'll talk more about the nature of the assignments and the homework and what they'll be grading and everything like that. But let's see here. I did want to give them, if they are on, an opportunity to introduce themselves. Alex, I see that you're on. Alex, do you want to come off mute and introduce yourself?
Yeah, I can do that. Hey, everyone, I'm Alex. I see a lot of familiar faces here. So it looks like I sold the class to people. That's great. I took the class over the summer and it was great. It was fantastic. I loved it. And I'm really happy to be back as a grader. Yeah, I don't really have much more to say except for strongly advise, I'm sure David will hit this home too, to watch the lecture videos on the website. Don't fall behind on those. Those will keep you up to date on a lot of the great stuff that you'll be learning. But yeah, I'm happy to be here, happy to be your grader, and just looking forward to doing stuff.
Excellent. Thanks, Alex. And Lakshmi, I didn't look. Were you able to join us? She might not have been able to. Didn't book the option. Let's see here. Nope, don't see her, but they'll both be supporting all of us this term by providing feedback on your quizzes and on your programming assignments. And so that's an important aspect of the course, is to let you know how you're doing, help you understand which concepts that you grokked and which ones that you still need to work upon. So good. Thanks, Alex. And feel free to drop off because we're paying him for this. So he bills in 15-minute increments too. Yeah.
Good luck, everybody. Have a good night.
Thanks, Alex. Good deal. Oops. So this is an Attend Anywhere class. And ever since we came back to campus, or rather campus was open again, I'm going to say during the pandemic, so I'm not sure it's over yet. I've offered this as an Attend Anywhere. For me, I feel that's the appropriate option for this class. What we're able to do, I mean, we're able to deliver this class remotely because most of it can, well, actually all of it can be experienced outside of the classroom. But really, your safety and your ability to engage in the course is of paramount importance to me. This is 11 weeks out of your life, and there's a lot of other things going on during these 11 weeks, and I want to make sure that everybody has the flexibility in the environment that they need to feel that they can give their best to the class. You can come to the classroom or you can be remote. The way this class works is that there's presentations in class, discussions, activities, all the stuff that we do will be available over Zoom if that works better for you. And so when we collaborate, we'll be in breakout rooms. And my office hours will also use Zoom. And so, to be clear, if you're not feeling up to coming to class for whatever reason, you have the option not to. So, whether, hey, you've got cold or you've got the flu or, hey, just life isn't letting you, it's not the right day, I want to make sure that you've got the option. That being said, I like to see people in class. I miss people, and so it's good to be here. I will be here unless I'm ill every Wednesday, and so feel free to join me here. From what students have told me, it's a little different experience being in the classroom than it is being remote, but do what works right for you. So everything in class is going to be recorded and available on YouTube, plus all of the lecture material. I flipped the classroom years ago, and so all of the me telling you about Java stuff and everything, that is on YouTube. All of the quizzes and exams, including the final exam, the surveys that we do, it's all through Canvas, so that can all be done remotely. And then I prefer using Slack for day-to-day communication, and we'll talk about how to get signed up for that and everything. I don't use the CS department Slack, so I like to have multiple channels and everything like that. So we've got, I know it's another Slack workspace to deal with, but you'll deal with it, you're smart people. So anyway, these are the tools that I provide to support and Attend Anywhere class. Please let me know if there's anything else that I can do to help you engage and get the most out of the course. Like I said, I've been teaching this course for a number of years, probably longer than some of you have been alive even. And so there are lots of people who want to take it. That's great. I'm really proud and I'm really honored that it's so popular. As a matter of fact, we are registered full right now at 50 students. Turns out that this classroom can accommodate 65, so I can add some more people in. And so then please, if you are on the wait list and if you want to come back after today, let me know and I'll get you enrolled in the course, no problem. So despite it being large, despite it being attend anywhere, we hope that we can provide you with a really great learning experience and that you are able to gain a lot out of it and have some fun along the way. So we got a lot more to cover tonight, but I wanted to start off with any questions that you have about sort of the initial mechanics of the course. Actually, let me get the chat. Oh, the chat's up here. Okay. Wait, yep. Can I ask about the Nobel laureate thing on the page? Yeah, so go look at the source code. I have, oh yeah, this one says playing easy listening favorites of the 60s, 70s, and today. Yeah. It is like me trying to learn JavaScript and ooh, look, there's a random, and me trying to learn JavaScript in like 2001, by the way. So if you look at the JavaScript, it's pretty laughable by today's standards, but it still works because backwards compatibility. Nice. Oh, and someone created a Discord study group. That's awesome. Thanks for doing that. Just realize that I'm not going to pay attention to that. So if you have any questions or things need to be clarified, or if someone's making a statement about like, oh, the assignment date was changed, the official communication will be on Slack. Let's see here. Oh, IntelliJ Community Edition, is it acceptable? It might be good enough, but I really encourage you to get the student license trial. You'll get more functionality. I can't remember how much GitHub support there is in Community Edition these days. So I guess the real answer is I don't know. So give it a try. Let me know what you think. Okay. Let's take a look at the syllabus. No, I don't want to full screen it. But I'll make it a little bigger. Get rid of this thing. Okay, so I want to have a goal statement for the class, and what I hope that we can all accomplish is learn about the Java programming platform. So that's the language, the runtime, it's the APIs. You'll be building web applications, all sorts of great stuff. So it's lots of good Java stuff and lots of good software engineering stuff, and to have fun doing it. We're all here for 11 weeks together. I hope we can enjoy most of it, but it'll be tough, right? It's a good challenge. I hope you get a lot of it along the way. So the way we'll go about doing this is that we'll have I've got the lectures that are posted online on YouTube. And so here in class, really what we do is we code together. At the beginning, you'll be watching me code and we'll talk about it. But as we get into it, let's see here, 6 out of the 11 classes, there will be an opportunity for you to work with other people writing code. This is, I found a really good way to learn because you can learn from each other and learn from others. Learn from each other and teach others along the way. I also have provided a lot of code examples. They're mentioned in the lectures and they're all on my GitHub repository. And actually, you can look at my GitHub through here. Actually, is this full? Yeah, okay. Let's see here. My GitHub is. Is it over here? Yeah, there you go. Yep, it's just David Whitlock, Portland State Java. This is the source code for all the examples that you'll see. We'll see there's another repository for getting started, which is what really you'll be interacting with. But this is where I have like all of my code that shows how to use a lot of the Java APIs and do a lot of the things that you'll be doing in your projects. And speaking of the projects, let's see here, there are 6 phases to the project. And it's a project that you build up a little bit every week. And so there's a series of assignments. You'll be starting out with writing some very simple Java classes, and by the end, you'll have an Android application that is, that models an interesting domain that you've been working with the entire course. As we'll see, that constitutes the bulk of your grade, but there's also quizzes and exams that give you an opportunity to demonstrate a more qualitative understanding of what you've learned, and gives you feedback on how you've understood more of the concepts behind the course, in addition to the practical application of what you've learned. So here's what we're going to be covering, while here in class, again, what we see is a lot of code which integrates the concepts from all of these. This is like what's covered in the lectures. So I kind of, let's see here, I hope everybody's seen Java a little bit anyway in your lower division courses, but you'll be learning a lot about the Java syntax, both through the lectures and also through the Koans. We learn about object-oriented design and programming, the standard libraries that come with the Java platform, so data structures from utility classes, how to do I/O, stuff like that. We'll be seeing a lot of test-driven development and a lot of unit testing of Java programs. Also learn about Maven, which is a build system for Java. And all this is part of the Java ecosystem. So as you build applications in Java, you want to have automated tests, you want to have an automated build system so that you can do complex things more easily. Sort of after the midway point of the course, we'll be looking at web application development. This is not like website development. We're not going to be learning HTML and JavaScript. I'm not going to throw a bunch more languages and stuff on you. Instead, it's really learning about the back end of web applications, how to build and implement a REST API in Java, and you'll learn a little bit about HTTP, the protocol. Not like HTML, the markup language. And then we have some more advanced topics that are covered, like the dependency injection pattern, which makes your code more testable and more better decoupled. And then also how to test code using mock objects in a way that you can have tests that are fast to run. Let's see here. And then we end with Android development. We do a couple of weeks of that. And the nice thing about Android is that you can develop Android applications in Java, and you can use it. You can use a tool that is essentially IntelliJ with some Android stuff added to it. So it's a familiar environment. It's not like you're taking a hard right turn in the last couple of weeks of class to learn something completely different. So those are the topics. Let's talk about grading. Always very important to understand. This is a program-intensive course, and so then what your grade is mostly based on is your demonstrated ability to program. And so then we'll see the first project assignment tonight. There's a multi-phase project that's built over the entire term. There's also the Java Koans project, so that's 60% of your grade right there. And so then I would like to program. Hope you came here to program because what we're doing. There's also 8 quizzes. We've dropped the lowest grade to let you have a bad hair day or whatever. And each one of those is worth 3%, so a total of 21% of your grade is on the quizzes. That's all administered via Canvas, which, by the way, actually, I didn't go to a different. Here's the Canvas homepage. Actually, let me go to student view, so I don't know what you can see. Besides magenta, that's nice. So Canvas is still kind of new to me. I know it's been used for like 3 years or whatever, but I've been here a long time. So most of my content is still here on the webpage, so I recommend that you start here. But the nice thing about Canvas is that it has things like the calendar, so you can see when things are due. Actually, I just want to walk through that pretty quickly. So there are quizzes that are due. Actually, all the work is due before class starts, because I want you to be focused on class. So either if you're coming to campus or you're at home or whatever, I don't want you to be working on the project. I want you to be engaged in class and in lecture. So everything's due there, and there's a quiz just about every week, and there's a project due just about every week. We'll learn about the POAs next week. But I've tried to have things represented in the calendar here so you can understand what was due. I don't know what your other professors do, but hopefully you can manage everything together in Canvas. And this is where you'll have the opportunity to take the quizzes. I believe quiz 1 is open now. Or maybe not. Well, maybe it doesn't work that way. I don't know. Cool. So that's Canvas. In addition to the quizzes, there are 2 what I call reflections. It's an opportunity for you to talk about your experiences and what you learned pair programming and mob programming. Each one of those is worth 3.5% of your grades. Oh, actually, this isn't true. This term, there will be 3 opportunities to pair program and 3 opportunities to mob program, and you must attend, I think, 2 of each? No, we're going to call it 1 of each. But I encourage you to attend as many as you can. It's a unique experience, and like I said, it gives you a different kind of learning. And so then there is a D2L quiz that allows you to, in which you can reflect on your experiences, talk about what you learned, what it was like for you. And then the final exam is worth 12%. It's cumulative for the entire term, but it's only worth 12% of your grade. So if you're one of those people where it's like, oh man, I'm going to slack off for the first 8 weeks of the course and then make it up in the final, this isn't that course, right? You can't do that. I very purposely designed the course so that every week you need to demonstrate a little bit of progress, a little bit of your ability to understand the concepts. Now, with regards to the project submission, projects are due on Wednesday right before class. However, my policy is that there are 2 late days that you can use across the term. And so then, hey, if you can't get it done by Wednesday, or you discover a bug right before class and you don't have time to fix it, then you can use a late day. And so you get 2 of those during the course. You can also resubmit a project within 1 week of its original grading with no questions asked. And this is, hey, if you make a silly mistake and oh, the test case is failed or something like that, I don't want anybody to get a 0 because of that. So you can resubmit. Otherwise, my policy is that no other late work will be accepted. That being said, we're still, figuring out how to live and everything like that. So, hey, if you're feeling behind or if you need some extra time, please reach out. Don't suffer in silence. Here again, I want people to be successful. There are 11 weeks. There's a lot of time. And so then, this is the policy because I want to have something I can point to, but I also want to make sure people are successful. People sometimes ask, oh, is there a curve in this course? Well, yeah, I guess there could be. So I'm open to it. But given whatever 50 students, there's not much need of a curve. The course sort of gets a nice distribution with the normal grading system. So while I reserve the right to implement a curve, I probably won't, or at least history shows that I haven't had to because we get a nice distribution the way things are. I also want to caveat that it's conceivable. Again, I haven't had to apply a curve since 2003 or something because I've had so many students in the course. So don't worry about that. Note that this is there's a graduate section and an undergraduate section of this course, and the content's all the same. However, I grade each one, each section would get its own curve if there was a curve. But again, I haven't had to do that in a long time. Any questions on grading or anything like that? Let's see here. Looks like Max had a question about how much of a crossover is there between Java and Kotlin and C#? Will this course touch those at all? Nope. Plenty of Java to learn in this course. Now, just briefly answer that question though. Kotlin is implemented on the JVM, and pretty much anything you can do in Java you can do in Kotlin. There are some nice language features to Kotlin. There's a reason there is a language. Although it was probably primarily for legal reasons because of Oracle's copyright on Java, but Kotlin's nice. C#, more of a different beast than Java. They've kind of played language catch up over the years, but I will not be talking about Kotlin or C# in this course.
How are the programming assignments graded? Do you run them through like a series of tests and based off of the tests to complete, or?
Yes. Yep.
Okay.
And so then let's see here. All assignments except for the last assignment have a command line program that drives them. And the way I grade them is that I have a series of grading scripts that send various inputs into your program. And then the graders assess how well the output matches what was expected. So yes, and the nice thing about that is that it's this is why we're able to scale to having 50 students in the course, because I mean, what is it? The department gives us 1 hour of grading a week per every 5 students. Is that right? So we have 10. Yeah. So with 50 students, we have 10 hours of grading, which is like the quizzes and the assignments and things like that. And yeah, so I've tried to streamline all of that so that we can accommodate more students in the course. And I think that hopefully answered that question.
Yeah, sorry, one follow-up question with that. Those tests that you have, or is that something that we're able to run our program through, or are we reliant on just our own tests that we rate?
No, I'm not going to give. If this were CS 101, I might do that, but this is a 400 level course in a graduate section. Part of the assignment is, or part of what I'd like you to learn is how to understand an assignment and take a specification and think of all of the edge conditions and then implement tests for them, as we'll see next time. We'll go into the details. But there is a code coverage requirement for unit tests, for automated tests for the programs. So testing is a big part of the course, and so I'm not going to give you what the output is supposed to be. Instead, part of the assignment is figuring out how to respond appropriately in a usable manner to various inputs.
That makes sense. Thank you.
Yep. That question? Yeah, the same question. Okay, good. Nice. Okay. I feel bad to say this, but don't cheat, please. That's silly. We'll catch you. And I know you might think you're smart or you're changing variable names. I've got tools to figure that out. Cheating hurts you more than it hurts me. I don't know. Don't do it. So I'll give you an F. You'll refer you to the department. I'll call your mom, and I don't know what I'm going to do. Please don't do that. So we use a tool called Moss, which is old but tried and true to detect software plagiarism, and it's pretty smart. Those guys at Stanford know what they're doing. That being said, there's some nuance here that I want to make sure to call out. There's lots of this online, right? It's 10 anywhere. You're on Zoom. You're on your computer all the time. That being said, quizzes, even though the quizzes are online, you can't use online resources. So you can't Google the answer, can't look on Stack Overflow, things like that. And please don't use physical materials either, right? So, this is meant to be a closed, quizzes are closed book as if they were in the classroom. The official department policy is it's cheating to submit credit work that you did not create or allow your work to be submitted as the work of another student. Okay, well, there's some more color I like to put on that though, which is it's okay to talk with other people and draw pictures and things like that, but for the assignments, don't look at anybody else's code. The assignments are meant to be individual projects because I want everybody's grade to be mostly their own. And also, please don't commit your code to a public GitHub repository or some other public forum. And also resist the urge to look for maybe other students who have. Because I can go find those repositories too, and maybe I already have. So, and I can all input that stuff into the plagiarism software. So, hey, yep, it's the year 2023, and I'm sure there are some of you that I'll never meet in person. It's a very different kind of student-teacher relationship than has existed historically. But please do the ethical thing and the thing that's best for you, and certainly best for your students in the university, and not cheat. Now, one more thing. some of the work in this class is meant to be collaborative. When we're doing pairing, when we're doing mobbing, when we're working here in class and talking with each other, yes, that's where you can talk with other students. You can look at each other's code. You can give each other ideas. But everything else, the quizzes, the projects, everything like that, is individual. And if you're wondering, is this a place where I can work for someone else? Please ask. The last time I had a cheating scandal. Let's a little bit. I had a couple people cheat off of each other. I asked them, it's like, look, your code is like exactly the same. They're like, oh, well, I thought we could like pair program this course. Like, why did you think that? So I had to update the syllabus to be very explicit about that. And it sucks that I need to take like 10 minutes of everybody's life to tell them this, but don't do it. Boy, if I end up throwing the book at you, there's the link that I'll follow to say what I can do. So anyway, any questions about shooting? Yeah.
So I know that like sometimes when we're programming or whatever, we might run into like a problem that we can't like figure out without looking at examples or something of other people's code sometimes. So, so we might like Google it or whatever. So if that's like a specific situation where we want to implement something that somebody else has done, should we not do that? Or should we like credit them and say, I got this code idea from such and so or whatever, or something like that?
Excellent question, Kristen. Thank you. So the first thing, if you find yourself in that situation, please use the class materials first. It's not cheating to use the class materials and providing them for you. And so that's the place where I would look first for things, because a lot of the code online is like wrong. So do that first. And then, there is definitely a judgment call between like, oh, look, I found like a blog post that explains how to use this API in general. And, oh, look, here on GitHub is somebody's old assignment from a year ago. I'll just use that, right? I mean, I'm sorry, I'm relying on you to exercise appropriate judgment. So yes, and in general, if you find somebody's work to be helpful, please cite it. That is the professional thing to do, and also gives them credit. So I think that's my response to that question. Does that give you good guidance? And of course, always feel free to reach out if there's ever a question.
Okay, thanks.
Okay. So let's see here. The class website is where all of the content lives. There is a mixture of, well, let's see here. Like for right now, we've got, I have like a gazillion years ago, I used to lecture in class. We used to have like handouts and things like that. I still use that same format for anybody who wants to print them out or anyone who finds it valuable. So you can have if you want to make a hard copy or if just a PDF works well for you, that's all available here on the website. And then also most of the lectures have screencasts. Actually,
Welcome to Advanced Programming with Java at Portland State University. In this lecture, we'll learn about how to develop automated tests using the JUnit framework.
Anyway, that's me. I don't want notifications. Anyway, and so then this is, you can listen to me, a recording of me from a couple years ago, talking about the lectures in that way, talking about the course material, and that way here in class, a much richer and more interesting, hopefully more interesting experience than listening to me talk before I went every week. All that's up there. One of the things, I don't know if you did it tonight or not, but please review the lectures before coming to class. With the things we'll be talking about, I will have expected that you've read over the screencast. It's also a great time to ask questions. I have what I call Prime Minister's questions at the beginning of every class. It's an opportunity for you to ask questions about the assignment or just concepts that you saw, things that you might want to explore a little further. And then, of course, like when we code in class, there's things that you'll be seeing about Maven, things about JUnit that will make a lot more sense if you've watched the lecture already. So some advice that's built up over the years. Please don't wait until the last minute to start the projects. I know the first couple might seem straightforward, but history shows that they're a little bit more complicated than you might think. And so, and we'll talk next week about more details about submitting and how that plan of attack thing works, all that kind of stuff. We'll also talk next week about documentation requirements. And so then as you document your code, as you write your code, I encourage you to document it. I hope you're here to learn and not just like show off what you already know. So, I think we all need to, as students, we all need to admit that there are things we don't know. And so if you have a question, please ask it. Most likely, if there's something that you're not clear on, someone else isn't clear on it, and it's probably because I didn't make it clear. So then, please, find a way to get your questions answered. I know it can be super awkward doing it here in class, and so feel free to use the chat if speaking is not something you're comfortable with, and following up afterwards is fine too. I do encourage you though to ask questions in the channels, the forums, whatever they're called, in Slack. Yeah, what is that? Sorry, what is that? What are the things called over here? Channels, yeah. In a channel in Slack so that everybody can see the question and everybody can answer, or everybody can see the answer too. I know it's still early and people are still figuring out their courses for this term, but this is a senior level course. There's a lot of work in it. And if you're taking other courses, especially other program intensive courses, make sure that you understand the course load and feel that it's appropriate for you. I think the course is on track to be offered again this summer. And so then if you think you're still going to be around, still going to be at a student in Portland State, then if you haven't graduated yet, you can always take it then. Like I said, there are lots of code examples there for you to go home and play with, compile them, change them, help understand, read over the code to get a better to get a better understanding of how certain concepts are implemented. My office hours are held the hour before class on Zoom. I'll try to get down to campus at 4:30. Otherwise, we'll figure it out. And also, if we need to meet some other time, I'm also open. Please reach out and ask. Like I said, we're going to use Slack, and there's an invitation to the Slack in Canvas on that Canvas page. It looks like a number of people have already joined. Please be sure to join if you haven't already. This is the primary means of communication. It allows us to talk in real time. When there's something important in class, like I'm changing a due date, or hey, something is graded, go take a look at it. That's how I'm going to tell you about it. If you need to email me, probably the best way to do that is whitlock@cs.pdx.edu. Note that there is another David Whitlock at Portland State. I couldn't believe it, because if people started emailing Whitlock at regular old pdx.edu, and I'm like, I didn't get your email, I don't know what you're talking about, and then found out, and his name's David too. So if you, I know, right? What are they? Yeah. But they went all Highlander because there can only be one, and I don't know if the guy's here anymore. Anyway, but my PSU email is whitlowcd at PDX. So if you need to share Google Doc with me or whatever, that's who I am. And actually, my name shows up as David Whitlock Comp Sci to differentiate me from the imposter. I'm sure he's a nice person.
David?
Yeah.
I was wondering, could you show where the coding examples are again? I thought it was a repo, but I'm not seeing them on my board.
Let's see here. It's just the Dave on GitHub. So it's github.com/David Whitlock, just the regular.
Oh, it's a separate repo from the project repos. I see.
Yes, it's different from the getting started. Yep.
Thank you.
Yeah, and so it's like the examples and everything. No problem.
Thanks very much.
Yep. So let's see here. I don't know. The grader, I don't know if it's because I send stuff from the grader account and I don't know why. Sometimes the grader emails get marked as spam. So like if you see me post in Slack, it's like your stuff's graded, and you're like, I don't see the email, please check your junk folder first. And again, the course webpage is the authoritative source. And we'll talk more about this shortly, but there is a survey script that needs to be run on the PSU machines. And so before you can submit any of your projects, you need to run that. And so that is an important thing to do. We'll talk more about that. But you only need to run it once for the course, and we'll talk about that. So That's the syllabus. So that's sort of like the general overview of the course. Any questions about what we're going to do, how we're going to do it, what it all means?
Can I ask about the textbook?
Yeah.
I didn't see it listed in the bookstore links when signing up for the class, but I did see it on the course website. So I was just wondering, is this like a suggested thing or a definite thing?
It is a suggested thing.
Okay.
And it's, hey, some people learn best from a textbook, right? And so if you're one of those people and you're like, I want to have a textbook, I think this is a good one. It's actually pretty dated by now, actually. So, but that being said, I guess, boy, the last several years, I don't think anybody's really told me about using the textbook. So, unless it's something that you really want, you don't need to purchase it, because I'm sure it's not cheap at the bookstore. So, maybe a free online version these days, or probably has been. Let's see here, a couple things. Announcements are also useful in Canvas. Yeah, but I don't find Canvas to be that useful. So, please use Slack. There's something about the immediacy of Slack that works really well for me and works pretty well in general for students. Is there a quiz and assignment due every week? Just about. So if you look at the schedule, or if you look in Canvas, let's see here. Well, like quiz 1 is due next week on the 25th. Project 1 and quiz 1 are due. It's usually a project and a quiz every week. How long should we expect each project to take? That will be answered later in class, because actually I have data on that. It's data. Science. What is Koans? We'll be talking about that also later in class. Any other questions? So, how long do the quizzes take? I think the time limit on them is on average 20 minutes. I think some of them have a 30-minute time limit. The quizzes are like 3 short answer questions. So history shows that 20 minutes is plenty of time. Is there a break mid-class? Yes, there will be a couple. I try not to talk much more than an hour before taking a break. We all get tired. Me too, especially me. So we'll probably have another 15 or 20 minutes or so. Nice. I realized that I wrote some notes to remind me what to do, and I didn't get them out, so I'm going to do that now. So, yeah, go ahead and ask. Oh, oops. Okay, Slack me or email me or whatever, and I'll open back up for you. Well, did it time out? So, okay, good. So now you know. Okay, we did the intro slides, we did the syllabus. Okay, let's take a look at the Getting Started repository next. There is no midterm, right? Oh gosh, there's all sorts of things here. Wait a second. What sort of content do the quizzes cover? The quizzes cover the content from like the previous week. The first quiz is a little unusual in that it just talks about your programming experience. But like the quiz for week 2 will cover the content. Sorry, the quiz number 2, which is due before class on week 3, covers the content from week 2, essentially. So it's the stuff that you learned about in lecture and that you applied in your the assignment that was due this week. Let's see here. There's no midterm, right? There is not what I call a traditional midterm. There's a survey midterm because I want some feedback on how the course is going. But again, it's another 3-point quiz. It's something special. Are the quizzes multi-choice or coding? They're neither. They're short answer. There might be some coding in there. And sometimes the questions are about an API that you learned about. And let's see here. Can you explain more about the final exams? They're cumulative. It's 12% of your grade. It's on the last day of class. It's kind of like, are there something specific that you want to know right now? I'm not going to tell you the answer to number 4. Nope. Yeah. Oh, okay. Oh, you see there, final exams, folks, 11 weeks away. You got a lot of stuff to do. You know, if you're worried about the final exam now, check your priorities. That's 12% of your grade, 60% of your grade is the projects. That's what we need to be focusing on right now. So yes, there are two exams. One is individual, one is a group. I will give you everything I think you need to know on the penultimate day on week 10. We'll talk about that. How many hours will you have to submit the final exam? I don't remember. It's like 45 minutes or something for the individual part, and then you've got more time for the group part. See, back when all this was on paper, and like no, you know, I didn't have to do this, but now it's all on Canvas. This is good. Good. I'm glad you're all looking ahead. Okay. I'll keep an eye on the chat if more questions come up. Okay, so like I said, it's a program intensive course. We're going to be doing a lot of programming, and programming requires tools and requires structure and everything like that. So over the years, there was a time where students kind of really struggled to get started, and the first couple of weeks were really rough. And I thought, okay, what can we do to make that easier so that people can focus on writing code and learning about Java and less on setting up with tools? So I created this repository right here, the Getting Started repository, and I'll post a link to it in the chat. This is a GitHub repository, and let's see here. Are people familiar with GitHub? So raise some sort of virtual or actual hand if you've used GitHub before. Pretty much everybody, okay. And then people online are coming in. Okay. Good, lots of reactions, okay. So briefly, GitHub, so Git is a version control system. It allows you to have source code, which is, well, it's versioned, which means that you can make changes to it, and your changes are recorded. You know, it's like the blockchain, right? It's recorded, and so you can go back in time. You can, someone's here. You can, and it allows multiple people to contribute to one code base without clobbering each other's code, which back like 25 years ago, that was a big problem. You know, back when you sort of had to copy code around, it was a real pain, and so these version control systems were invented, and sort of the one that's won the market essentially right now is called Git. GitHub is a website that hosts Git repositories and has a lot of really great developer workflows and features and visibility built around it. And it's what I use for this course. I also use it professionally, and it works well. And so going to this site, if you then I have a big README file, which is what I hope. Well, is what I intend to what I intend for you to get started with in the course. So it has a lot. So let's talk about how to use it. First of all, you're going to need to install a couple of things. You'll need to install Git, which is a command line utility for interacting with Git repositories. You can also use it with GitHub. If you'd like, you can use the desktop tools if you're more familiar with that. I prefer the command line personally. And also, we'll see IntelliJ here in a moment, but it has really great support for Git, really great integration. And so, like, while I'm coding, I will use that. So you'll get to see you know, several workflows here. So let's see here. Now, this repository is something that I've been using for a while, and I'm trying something new this term. GitHub recently introduced the concept of a template repository, which means what you can do is that you can, actually, how do I create a template? It's up here, simple, isn't it? I'm going to find out like you will. Here again, I haven't done this for a while. So, if you make a fork of this repository, it has to be public. I don't want your code to be in a public repository. I want your code to be in a private repository. And by the way, you can get a private repository by creating a student developer account in GitHub, which will give you, I believe it's unlimited now, private repositories. And so then what you'll need to do is the following. I think this, let's see here. Here's some documentation here on how to create a GitHub repository. You can do it from the command line, but instead, okay, yeah, so you can say select create new repository. Oh, am I not logged in? Is that why I'm not logged in? That would do it. Nope. Sorry, I am going to let me go look at my password. So I'm gonna pause sharing. I'm gonna mute the AV here for a moment. Let me go off to a different screen and put the password. Oops. Ugh, it needs a verification code and security. No. Nice. Okay, I'm logged in. So then I will. So many pop-ups. Let me get the share resume. Let me turn that's all back on. Okay. Sorry about that, folks. Okay, now I have the ability, there you go. Use this template. So once you are authenticated with GitHub, you should have the ability to say, use this template. And so please create a new repository. I'm sure exactly what code space is. Create a new repository. And now you'll have the ability to make a copy of this repository for your own use. So I'm going to call this Portland State Java Winter 2023. Nice, it is available. I'm not going to call it animated octo garbanzo. That is strange. And let's see here. Interesting. I'm going to create a public so everybody can see it. I want to make sure that yours are private. And what this will do is make a copy of the repository for your own use, which will get you started with stuff in the class. So mine's going to be public, and let's see here, description for it. Sure, source code that we write together in Winter 2023 advanced. You can put whatever you want here. Advanced programming with Java. Let's see here, everybody. Yep. Okay, everybody can see it. Include all branches. I don't think you need to do that. Nah. Create repository from templates. Great. And now I've got a repository of my very own, which is distinct from that getting started one. Now this is the one I'm going to use for this term. And what this repository has is a whole bunch of things to, again, scripts to help you get started. It sort of gives you the Maven framework for everything. And we'll start using it here very shortly. So now I'm not looking at I'm not using my own repository now. Again, I want it to be private. I also encourage you to make me a collaborator. One of the things that I've learned over the years is that it's much easier for me to help students if I can see your code. Because someone will reach out to me and say, it's not working. I'm like, well, what's not working? Can you show me? It's like, great, I can see your code. And it's much easier for me to help debug things and get people going in the right direction. So invite me to be a collaborator, and I can help you with that. Once you've created this repository, you'll need to get a clone of it on a local machine so that you can work with it. Actually, you'll probably want to first clone it to the PSU machines. So maybe we'll do that. Yeah, actually, let's just do that here. And if you're new to GitHub, you'll need to authenticate with SSH keys or personal access tokens. And so I have some links there to get everybody started. Okay, so now let's go and, that font's awful. Oh, good, looks much better up there. Okay, so this is on my local machine. Actually, I'm not gonna, I'll leave it there for the time being. What I'm going to do is I'm going to SSH into the Linux machines. Yeah, it's the Linux cluster for the CS department. So I grade all. So your programs can be developed on whatever machine you want to use. You can use your laptop. You can use the system at home. If you want to, you can. I think IntelliJ is installed on some machines at PSU, but almost everybody uses their own laptop. I want to be able to support that, right? I don't have to bind you to remoting into some other machine. However, I'm going to test all of your code on the PSU Linux machines, which means that you need to test your code on the PSU machines before you submit them. So that's why everything here is centered around the PSU machines. Sorry, I'm looking at the chats here. All good stuff. Thanks for mentioning that stuff about the GitHub command line tool. Yeah, that's cool. Well, that's a good point, right? Yeah, so recently IntelliJ has added a feature where you can work with source code that's on a remote machine. And if that works for you, that's cool. The nice thing about GitHub is that GitHub is also really good at moving stuff back and forth. So what I'm going to show here is how to use GitHub to do that. But yeah, if you want to use IntelliJ to work remotely, if that works for you, that's great. So the first thing I'm going to do here is make a clone of this repository that I've created. And the way I'm going to do that is by getting an SSH URL to clone from. Now I have all my keys set up and everything, so I should just be able to say git clone. Oops, that thing. Why is it highlighted? That's weird. Okay. Oh. Nice, and by doing that, I then have, let's see here, Winter2023. I now have all of my files here that are in my GitHub repository. So all of this stuff. By the way, is this familiar to all of you? Have you kind of done this kind of thing before where you're cloning a GitHub repository? Because I want to show it to you, but I also don't want to bore you with things you might already know. So if you have questions, please feel free to ask them now or follow up with me afterwards. This kind of getting started and all of this stuff is just first day things. Once you have sort of the workflow of developing some code on one machine, moving it to another, it all works pretty well. Okay, so now I have my checkout on my PSU machine. That's good. The other thing that, yeah, so we've done that. The other thing that's really important to do is to have the Java development kit. Now, the Java development kit at JDK is the set of tools that you need to compile and assemble and run Java applications. For this class, you need at least Java 11. I think what's installed on the PSU machines is, what, Java 16? That's nice. That's nice and up to date. That should work just fine. And if you want to configure if actually, please log into your PSU machine, do Java-version, and if you don't see Java 16, or if you see anything older than Java 11, you'll need to update in your environment. And one way you can do that is using the add package command. And so this is a nice command line interaction interface that the CAT folks wrote a long time ago that allows you to easily configure your command line environment. So I've got Java 8 already selected, but what we really want, I guess it's called OpenJDK. So if you, I think you can actually literally click on this, or you can hit spacebar or something. Yeah, select that. When you click OK, it will update your execution path, and so it can find OpenJDK and this older version of Maven, which actually we don't even need anymore. Or if you're more comfortable with configuring your Unix environment, feel free to copy uwitlock.bashrc. This should be available to everybody. Yeah, you all can read that. And that, of course, then I'll have all the environment that I use. And the nice thing there, so this is like my path, and I've got all this stuff in there. By configuring your environment like mine, it's much more likely that there won't be a difference between the two when I go to grade it. Now, for your own machine, for like your laptop or your development desktop or whatever, you'll need to install the JDK yourself. And here I have a link off to adoptium.net, which gives you basically binary installers and RPM packages and all that good stuff for OpenJDK, which is the free version, free and unencumbered version of the Java development kit. So I encourage you to do that. I've validated the source code with everything up to Java 19, so I think that's the latest. But Java 17 is the long-term support, the LTS release. Feel free to use that. And so that it's easy to install it there. I'm not going to go through the process. Right on that. And make sure that when you've that not only here, let me go back to my local machine. This is my local machine. Oops, this is a dumb place to be. I'll make it a little bigger there so you can see. Like again, my Java version over here is 17. And you also want to make sure that your Java home environment variable is set, because things like Maven will use that. And normally when you install from Adoptium, there'll be a step that lets you set the Java home environment variable. Please be sure to do that. So again, I'm not going to walk through this process because there's lots of good online resources. Let me know though if you encounter problems. It's super important to have the Java development tools available on your system. Oh, someone noted that cloning a Git repo in Linux server gave me an authentication error. On local machine, it worked fine. I don't know exactly how to debug that off the top of my head. Give it another try, and if you're still struggling with it, please reach out on Slack. I recommend the general channel. It might be that your fellow students have more information than I do about how to get around that. Okay, so you have made your own copy of the repository by using the template. You have gotten a checkout here on the PSU machine, and you've made sure that your Java is the right version. Now it's time to start doing stuff. Now, as I mentioned before, in order to accommodate so many students in the class, I've had to automate a lot of the drudgery, a lot of the toilsome things that are involved with administering a course. Things like submitting assignments, right? Back when I was a student, like we gave floppy disks to our TAs and things like that. Or maybe for some of your other courses, you email your professor, or you upload something through Canvas. The graders have limited time. I don't want to use their time. I want to use my own time doing things like clicking on, downloading something from Canvas. So since the beginning of this course, or maybe the second term I taught it, I wrote a program that will submit code that you can run to submit your code. And basically what it does is it zips it up and emails it to the grader account. And then I have code that will go download that email, extract things in the right place, and then it makes it really easy for me to test things. Because this is good, because I'd rather much be spending my time helping you as students, answering your questions and developing compelling content, all that stuff, and not like doing a lot of click and drool. So, however, all of this is based on me knowing who you are. So the first thing that you need to do before you can create any projects, before you can submit anything, is run the survey script. This also validates that your environment is set up to run Java programs. So there's lots of reasons why you should do this. And the way that you do what you do is, let's see here. Oh, is it not? Oh, the survey. You run the survey. Oh, and by the way, whenever I run things on Unix, or also my Mac, I prefix it with / because not everybody has / in their file path, and / is the current working directory. So anyway, I might do just survey.sh, or I might just do /survey.sh. So I run this script, and this, by the way, this script only works on the PSU. PSU servers. It does, it does a couple of checks to make sure you're on the right machine. And the reason it only runs on the PSU machines is because it ends up invoking some code that lives in a jar file. We'll talk about jar files later. It's basically where Java code lives. That's in my home directory, and so it's got to be able to find the code to run. And this is how it does it. It checks to make sure that you are running the right version of Java. It says yes, you are. And now it's saying, hey, we'd like some information. So I'm going to put in my information and nickname. I don't know. Probably good.
Does it matter which like directory we're in? Like, I know we have to be in our student directory, but like if we're in subfolders or something, does that matter or what?
It does, actually. So the survey program is expected to be run from the top level directory of your checkout. So I called mine Portland State Java Winter 2023, and I made a checkout of it. That's where the survey program lives, and yeah, it expects to be run in that directory. It's going to create a file called me.xml that needs to live in that directory.
Will it just not run if you try and run it in a different one?
I don't know. I've never tried it. But actually, if you've gotten so far that you've been able to create the student, then you've already run the survey, right? You only need to run the survey once.
Oh, okay. So if it works, it works.
Yeah.
Okay, cool.
So, thanks. Okay. So I asked it first name, nickname, things like that. What's my login ID, Whitlock. And the reason that I asked for this is actually we use this when generating the projects, and you'll see how that works after the break. Email address. And I just gather all this information so that you can tell me exactly like what email address you want to use and how you want to be addressed and everything like that. Maybe that information is like in Banner someplace. Like no. You just tell me what you want, and then we'll be in good terms. I want some demographic information, like what's your major, undergraduate or graduate, and then just some. Hey, this is an opportunity to sort of say, hey, let me know what you want to learn. I want to learn a lot. And no, I don't know anything. Nope, nothing. You can give more nuanced answers. It's going to come towards your grade. Don't worry about it. And then it tells you that it created this me.xml. That's important. We'll see in a minute. Now I want to verify that yes, all that information is correct. So it does then takes that me.xml file, sends it off to the grader, and it reminds you that you should commit me.xml to your Git repository. The me.xml, we'll take a look at it here, has all this information about you. And I use this XML file in the, I use this in my gradebook. So this gets sent to me, I then extract it, and I use it in a gradebook program that I wrote. It's also key to the automation for doing things like taking your submitted work and noting it on your behalf. and tying everything together. When I grade your projects and I then email you the results, I use the information in this file to send you the email. So this is why I need all of this stuff. And again, I have you do all of this so you can tell me the information you want, and also so that I don't have to like go through and do a whole bunch of cutting and pasting from, you know, again, Banner or Canvas or whatever. You tell me what email you want, things like that. Now, this file, yeah, you want to commit this file to your GitHub repository because it's used by other scripts, and we'll see that again after the break. So you do that by doing, well, you can do git add, but I'm just going to commit directly. Add a file all about me. And actually, I probably have a better, there you go. Add information about myself to the survey program, sure. That sounds good. Let's use that. Cool, and now I will do a git push. Ugh. Sorry, I'm gonna add my key so I don't need to type my passphrase once. There we go. Nice. Okay, so I added a file to Git, and now when I refresh GitHub here, I'll see that I just added this information about myself. There's me.xml. So if you've gotten this far, you have created a GitHub repository, you have checked it out on the PSU Linux machines, you have configured your Java environment so you can run Java, you've run the survey program, which uses Java and everything like that. You've created this me.xml file and you've added it to GitHub. And now you're ready to create projects, which we will do after we take a quick break. Any questions first? I don't even know why I do that. Who's gonna say, oh no, let's sit here and talk for a second. Okay, we'll see you all in, let's do 9 minutes and come back at 6:15. Gordon. Hey everybody. Oh, you know, actually one thing I wanted to ask people who are remote, is the audio coming through okay? Previously, sorry, what? Oh, you're listening to the audio. I was like, dude, you're right here. Yeah, okay. Good, okay, good. Because previously I've had a headset. When I was listening to one of the recordings, it sounds like I'm, like, is your captain speaking? I was like, I didn't like it. So good, okay, cool. Because yeah, the microphone on this is usually pretty good. Excellent, okay. So welcome back. Hope you got to refresh during the break because we got a bunch more stuff to cover tonight. So in the beginning of class, after covering the syllabus and stuff, we started diving into this Getting Started repository, which should get you all set up to do work in the course. And so we created the repository. We have configured our environment so we can run Java. We have run that survey program so that you can provide me with some information about yourself. We've committed that me.xml file so we don't lose it if you're going to need it. Now we're going to create a project. Now, Java projects consist of a number of files. You've of course got the source code, the project that you're writing. But then you also have automated tests for it. You can have documentation for your Java project. And there's a tool called Maven, which puts all this stuff together. It'll compile your source code, it'll run your unit tests, it'll build your documentation, all sorts of great stuff. We'll be using it a lot in this class. There's a lecture all about it, and it's something that I'd like you to watch, so you can understand what we're doing here. However, getting started with all of this stuff, getting started with Maven, creating the right directories and everything like that, it's kind of tedious, and especially for the first day, you've never seen this stuff before, and I want you to get coding as soon as possible, not have to worry about that. So one of the big benefits of the Getting Started repository is these shell scripts, and there's one called Create Student Project. Now, the student project is an example project that I use here in class to demonstrate some test-driven development, to show you the kinds of things that you'll also see in your real projects. You do not need to create the student project. You can if you want to play around with it, following the steps, that's absolutely fine. It's not a requirement. You do not need to submit it. Actually, don't bother submitting it. I'm there's nothing, I suppose I can try to provide you feedback, but you've got other projects that you need to focus on. Instead, I'll show you how to do this, and then a little later in class, we will see how to create the first project. So, I'm back here on the PSU machine because this is where I've actually got my source code. So I'm going to run create the student project. And actually, create student project uses that me.xml file. And what it does is it gets information out of it. Primarily, it gets your Unix login ID, and it uses that Unix login ID in the source code. So it is running Maven. And what it's doing right now is downloading all these things that Maven needs to do what it does. So that's one of the great things about Maven, is that it manages all of the libraries, all the third-party code that you'll need for your project. So for instance, we've seen something called the JUnit framework, and JUnit is an open source library that you then need to download and include in your Java project. Maven takes care of all of that for you. So what this has done is that it has the script creates a new Maven project for you, and you'll notice that the Java package, which is and also the group ID for the Maven project, which you'll all learn about in the lectures, has Whitlock, has my name in it. It gets that from the me.xml. If you're doing this, it'll have your login ID. And I want this so that I can distinguish each one of your source codes, so that your ID is there in the source code. So what this does is this creates a directory called student. And student has all sorts of stuff in it. It has something called the Maven W, which is the Maven wrapper, which is a script to run Maven. And it has some source code. And there's different kinds of source code. There's your main source code, which here is all of your Java. And so there's a student.java, which is a Java class that we'll be looking at. Actually, we'll look at that shortly. I'm not going to look at here in minutes. Let's see here. What do I say that we should do now? Okay, so the first thing that we should do is add that code to the, so you run the script, and the script creates a bunch of code here, and now you need to add that code to your Maven repository, to your GitHub repository, so that's under version control. Because if I do yes, question?
Oh, sorry, I was just, before it goes, is there a way that we can, like, command line to see all that info again?
Yeah, let's see here. If you want to look at it here, I mean, you can just do LS's. Do we have an LSS tree on this machine? No. -R for recurse. Yeah, you can do this, I suppose. It's kind of hard to read, but here's all the stuff that gets created. Cool. So if you do an ls-R, you'll be able to see all that.
Thank you.
Yeah, nice. If you do a git status, this will show you everything that has changed. So right when I created the repository, that's got, and that has the files in it, and I made some changes, like I added that me.xml, I committed it. Now I've run that create student script, and that has changed something called the pom.xml. The pom.xml, POM stands for Project Object Model. That's the thing that describes your Maven project. And here again, watch the lecture. I'm not going to go into that tonight. And it added a directory called student. So now we want to git add student. And now if you say, so that adds it to the, basically puts it under version control. It doesn't commit it yet. It doesn't commit it. But here are all the files that got added. And so now I'm also going to add the modified pom.xml. Oops, add pom.xml. Now here are all the changes that are queued up to be committed. So I'm going to go ahead and commit that. I'm going to say git commit that -m for message. Added student project created by a student project created using create student. We should all create student project. I think it is .sh. All those got committed to GitHub. Those are now in my local repository. I want to take those changes and put them up on GitHub so that I can get it on a different, so I can easily get those changes on a different computer. So I'm going to say git push. That pushes it up to GitHub. And now when I refresh this page here, I can go up and the latest commit is added that stuff, and now I have a student project. And so all of those files that I added are now here in GitHub. So I've created that student project. This is one thing I want to do next, is I want to build that project. So again, what Maven allows you to do is get in one-stop shopping. It will compile your code, it will run your unit tests, it will package things up, and you can go from there. And so then if I can use the Maven W command, which is a script that invokes the Maven wrapper. It'll actually download Maven from the internet and run it for you so you need to install the tool. And I want to say verify. As you'll learn about in the lecture, there's all these different phases of Maven. Verify is kind of the last one. So it says, hey, go do everything for this project, starting with compiling the code and running the unit tests and run what are called integration tests. We'll learn about those next week. And finally, verify that everything passes. So this is sort of the whole kitchen sink. So the first thing it does is it downloads Maven and has to download a whole bunch of other things for it to run. The nice thing is that you don't need to worry about this. By the way, it puts all those jar files off in your home directory so that if you have multiple projects going, which you will eventually, things only get downloaded once. Particular versions of artifacts only get downloaded once. And it was successful. Well, what did it do? It spat out a lot of stuff. So let's go back and look at what it's doing. It's scrolling up. You know what? I'm going to run it again for all those. You don't need to download all that stuff. So what Maven Verify does is it first compiles your code, then it runs the unit tests, then it runs what are called integration tests. It builds API documentation, and then verifies that everything was successful. And if you see this build success, yay, that's a good thing. Now we'll talk more about some of this stuff later, because also does things like analyzes code coverage, but that we'll save that for next week. Okay, good. So now I've demonstrated that I can build my project, including running all the tests on the PSU machine. Very important step. This is the thing that you want to do before you submit. As a matter of fact, the submit script, which we'll learn about next week, does that. But this is on the PSU machine. I don't want to do my development on the PSU machine. I want to do it on my local machine. So now let's see how to do that. So here I am on my local machine. You can tell because it's an even uglier font. Actually, it looks way better on the screen than it does things more here. It's good. And now I want to make I want to clone my repository here to my local machine. Right. So what clone does is it creates on the local file system a copy of the repository, and because you're cloning a GitHub URL, your local repository is connected back to the GitHub repository, which you can tell by doing get remote -v. This is basically saying that it has a repository that my local repository is associated with a remote repository called origin, and when you push, it'll push to the origin by default. I'll do the same thing here. I will clone my repository here on my local machine. Oops. Let's say Java Winter 2023. And it's got everything that's there. It's got my me.xml, it's got my student directory. So the first thing we're going to do here is go to my student directory, and I'm going to run maven w verify. So this will go through and build everything. Actually, it's really important to make sure that things work from the command line with Maven before doing IntelliJ. Because what this will do is download all the artifacts that you need. And otherwise, IntelliJ can get a little confused. And so then, yeah. Now, note that I used the Git command line, which is my preferred way of doing it. You can do the checkout through IntelliJ, and I've seen students do it. It works most of the time. And so then if you don't want to use the command line, or you don't want to use the GitHub file system, the GitHub plug into Windows, or whatever it's called, you can go ahead and use that. You can also try to use IntelliJ, whatever works. Okay, I've made a checkout of my repository. Now I'm going to open up IntelliJ. So IntelliJ is an integrated development environment, IDE. I never know. How many of you have used an IDE, like Visual Studio or a little bit and stuff? Okay. And it looks like few people good online have also. Excellent. You know, for many years, I developed, you know, using Emacs and using sort of character-based stuff, and it worked well. And then I started using IDEs, and I was much faster. And so then it's good to know both. And hey, maybe if you are like a die-hard VI user and things like that, okay, you can try it. I'm not going to help you if like you get things messed up or and stuff. And actually, I think it's a good learning. It's good to learn new tools, and you know you're paying all this money so you can learn things. So give IntelliJ a try. Let's see here. I probably have some words to say about IntelliJ. That rhymes. Code. Gotcha. Okay. Work with code using IntelliJ. Right. So I have a link off to IntelliJ here. I encourage you to get the Professional Enterprise, whatever it's called, the full edition of it, and sign up for a JetBrains student account, which I think you can just connect to GitHub or something, and get yourself an academic license. It works for IntelliJ. It also applies to their entire suite of tools. So if you do a lot of Python development, PyCharm is a great IDE for doing Python, and they also have CLion for doing C code. Great stuff. So do that. It's also really important that you configure your Java development kit for IntelliJ. Usually it gets it right, but if you don't, you'll have to do that. Otherwise, you won't be able to find like sort of core classes like Java lang string. So if you see a whole bunch of red, meaning you can't find a whole bunch of stuff, check to make sure that your JDK is configured in IntelliJ. You can also run Maven commands from IntelliJ. It works most of the time, I guess. I prefer to do it on the command line. And so let me open up IntelliJ. Let's see here, I think I've already done, yeah, okay. And so then, gosh, I've got a whole bunch of things here. What I'm going to do is, now you can say Git from CVS, and you can, actually a really great integration with GitHub. So if you want to start that way, you can. I prefer to start on the command line. So I'm going to open an existing project. And here I am, and I want, here we go, I want Java, I want Portland State Java Winter 2023. And I'm going to select the pom.xml. So again, this is the Maven project. And one of the cool things about IntelliJ is that it knows Maven. And so when it looks at a pom.xml, it's like, oh wait, this is like a whole Java project. This isn't just a one source file, this is a whole thing. Do you want to open it as a project? And say, yes, I want to open it as a project. And it'll do that. And so it will scan the files in your GitHub checkout, in your project, and it will organize things appropriately. And so what this does is then IntelliJ will analyze your Java project, and then it will know what source code is, what code is source code, what code is test code, and it'll let you, start using all of this stuff. So, oh look, it's looking at the pom.xml. We will not go into details about this tonight. And it also has the README. I need to see that. But basically over here on the left, you have the project view, which allows you, basically gives you like a file system view of all your files. And here in bold, it indicates that it is a sub-project. So when we create our student project, it's a sub-project. And here it has all of the files. You can tell sort of things are working because instead of having a whole bunch of directories for the name of your package, it recognizes it as a Java package and it has one class, you can tell it's a big C, for a student. And so when we ran our that create student project, it created this source code. It created, let's see, does this, does that work? Oh, it does, cool. It created this file. And by the way, this is IntelliJ. So what IntelliJ does is it gives you a way to view your source code, to navigate your source code, and to work with your project. So you can do things like build a project, you can run tests from IntelliJ. And what we're seeing in this course is that you can use IntelliJ to get very rapid feedback on changes. And you want that so that you can make small changes. Because, well, as we'll see, a key to fast, safe, efficient software development is working in small chunks, in small batches. Right? We've probably all experienced this, right? Where you've like written your entire project and you've been 12 hours staring at the screen and it's 3 in the morning and you think you have everything working and everything seems to work 1 minute, the next minute everything was broken and you're like, why is everything broken? And it's probably because you've made too many changes and haven't validated things. So working in small batches is awesome. And something that takes a lot of discipline. It's taken me a long time to figure out sort of how to do it and to force myself to do it. But once I have it, it's really made my life a lot better. So we created some source code here. And let's see here, where do I want to go next? What else to say about getting started? Okay, this is probably, okay. Yeah, so okay, now we've got IntelliJ up and running. And by the way, is anybody playing along at home? Anybody who's on the chat or anybody here in the classroom sort of following these directions? Is anybody encountering things that are surprising?
Yeah, I did. My student file or my student directory has, like, to access the source, it's got a huge long bunch of directory paths to get to the student.java. And I think yours only had like one?
Nope, mine has several. So as we can see up here in IntelliJ, actually, well, sorry, people in the classroom can't because merfed. Anyway, sorry. It is in, so mine is in the student directory, and you have source, main, Java, edu, PDX, CS410J, and then you have whatever your login ID is, student. Do you say something equivalent?
Oh,
so that's
yeah, no, that's what I see.
Yep, yes, okay. And that's all on purpose. So that is the right thing, and that is purposeful. And here's why. You'll learn about this in the lectures. Java, oops, let's go up one more line. Java has classes. Classes represent things. I hope you're familiar with classes and methods, at least in other programming languages like C++, maybe Python also. So they have classes. And in Java, classes are in these namespaces called packages. And conventionally, packages have multiple components that correspond to the organization that's creating the code. So our packages for this class all begin in edu, PDX, CS410J. And then to distinguish various people's code, it's CS410J dot your login ID. And so when you look at code, most, I'm trying to think, boy, the vast majority of Java classes that I've encountered in my career have, at least two sections of their package. So the packages are this long hierarchical thing. Well, it is a hierarchical thing.
Oh, so each of those directories represents a part of that, like a
exactly right.
Okay, that I didn't make that connection. Thanks.
No, thank you for asking the question, because it's a concept. I don't know if it's super important, but you'll see then that to keep your code organized. And remember, Java came of age in a time where everything was on the file system, so organizing your code was a pretty important thing, because you weren't necessarily dealing with this nice IDE, you had like VI or whatever, so you really need to, the files were very important. You have, actually I think the compiler enforces it, you must have code that is in a directory hierarchy that corresponds to your package hierarchy. It's just the way it is. Actually helps keep code organized. It's nice. But yeah, it does mean that if you're just, creeping around in the file system, things are kind of far away. Because Java says the student.java file must live in edu, PDX, CS410J Whitlock. And then Maven says, well, all your source code should live in source main Java. So your observation is completely valid, where it's like, wait a second, my class is like way far away from my student directory. Yes, it is. The thing about IntelliJ, though, is that it hides a lot of these details, and so you can navigate the classes much easier in IntelliJ.
I have a question.
Yeah.
Earlier, when you opened this project, you had selected that pom.xml.
Yeah.
From like the parent directory. There's also one within the student directory. Does it matter which one? Like if I just wanted to work with the student stuff? Okay.
Yes. So you can open up in IntelliJ, you can open up the student POM. And it'll work, but then as we'll see later in class, we'll create another project for your project one that will be in a sibling directory of student. You'll have to open up another IntelliJ project for that. The reason that there's that top level pom.xml is that you can have ultimately one parent Maven project, and therefore one IntelliJ project that will handle all of the sub-projects that you'll create in this course. So I recommend that you work at the highest level. That will give you the broadest view of things, and I think it'll just in general make IntelliJ happier.
Okay, cool. Thank you.
Great questions. Okay. Let's take a moment and talk. Actually, no. Actually, I think it's time for the group activity. Yeah, let's do something a little different for a bit. So, and we'll come back to this afterwards. But I want to hear from you all about some stuff. So. Our experiences. Oh my gosh, what is it doing? Introducing pages format. Well, actually, I kind of do want to try it, okay? And I don't need an outline. So I think what I've offered this course like 3 times attend anyway, so it'll be the 3rd. And before that, I had 2, maybe 3, only 2 offerings that were fully remote. Drove my family nuts, me teaching in the living room and so while I think we all have experience, I want to hear about your experiences with remote learning. I want to understand what works for you, what has been effective, what hasn't been effective, and if you've got any ideas for this class. So, and I'd like to give you all an opportunity to meet and chat with each other. So here's what we're going to do. I have a Google Doc, and I'll share it with everybody shortly. But what I'd like, actually, I should have created even more rows. How many rows can I create? Put all the rows. 20 rows. Great. So I'd like to learn about your experiences with remote learning. So I'm going to put you into, I'm going to put you into breakout rooms, and we can have 1 or 2 groups here in the classroom. There are whatever, 7 of you. And so I'd like each group to populate the below table, and then we'll talk about it. So I'd like you to capture things that have worked well with remote learning, things that haven't worked well, and any ideas that you have for this course. So if you've got something you want to try, or something that you just want me to know about, please put it in that column. And let's see, where's the background? Where's the background? There it is. That's going to be a nice idea. Nice. So I'm going to put everybody into breakout rooms, and we'll have like a 10-minute discussion. And let me share the document right here. Nope. I want anybody, anyone with a link can view. No, I want anyone with a link can edit. Viewer, editor, done. Nope. Hello. Copy link. There we go. Oh, yeah, sure. Yes, please. Folks in the room, yeah, please contribute also. There's the link for the remote learning discussion. Yes. So yeah, it looks like some people are already there. I am going to break everybody into breakout rooms. Let's see how we've got, and I'll let you all choose a room. It doesn't tell me how many people are here. 38. So let's do 8. Yeah, 8 breakout rooms. Yeah, a lot of people. Nice. And I will open all the rooms. And so yeah, please go assign yourself to a room. And let's see, I'll pause the recording. And yeah, at 7:30 we will reconvene. And I'll ask each room to report out on what they discussed and anything that was particularly interesting.
This meeting is being recorded.
Thank you. Yeah. Hey, everybody, welcome back. Let's do a quick around the horn. Of course, now I got rid of where are the breakout rooms, which I hope this will have. Okay, good. I'm really curious about what you all discussed and everything. Let's start with people here in the room. We'll probably try to get on Zoom all this. Pair it back. So in your discussion about remote learning, what were a couple of, maybe we just highlight one thing because we've got so many rooms. So what was one thing that you want to call out that worked well, one that didn't, and if you have an idea, what would you like to share? You're all really chatty, like 3 minutes. Right?
Is that open to anyone to answer?
No, it would be people here in the physical room first, and then I'll go around to each breakout room. Thanks
Got it.
Yep, no, that's right. Recorded lectures, yeah, really helpful. Okay, good, got that. And generally, in class time will be. Right. How about things that haven't worked well? What didn't work well for you all? Ooh, so slow responses from professors and TAs and stuff like that. Yeah. Okay, cool. Any ideas? Anything that you've seen work really well someplace else that hasn't already been mentioned that you want to apply to this course? Sorry? Oh, yeah. We had an interesting conversation here about sharing things that in general aren't going well with us. Like, hey, man, there was something with the project that was due this week that I really struggled with. Calling those out for, first of all, learning, but also an opportunity to sort of be vulnerable with other people and acknowledge that, hey, we're all learning. There's things that we do know. There's a lot of stuff that we don't know. And that we're here to explore the things that we don't know, as uncomfortable as that can be at times. Great. Thanks, folks here in the room. Let's start with breakout room 1. Oops, I'm getting some feedback. Is that for me? Okay. So let's hear. Breakout room 1 was Adam, Devin, Clara, Theo, Sean, and Tanner. Could one of you come off mute and talk about one thing that you discussed that worked well, one that didn't work, one that hasn't worked very well, and then any ideas that you want to share?
Sure. One thing we talked about working well was just general like flexibility, like no commuting. It's easy to get to class on time if it normally takes you forever to get to campus, etc. The obvious, right? One thing we talked about that didn't work well was just general like distractions at home. Be that other people you live with, family, kids, pets, other stuff like that. That could be really difficult. And one of our ideas for the course as potentially spending more time like we just did, like in breakout rooms, having little like workshop-y sessions where it's easier in a smaller group to like, for example, troubleshoot some of the install stuff we're doing this week.
Great.
Harder to do by yourself or like over Slack.
Excellent. Yeah, and as far as setting up your environment, I encourage you to work with each other. And so, yeah, hey, actually, can you all create Zoom meetings with your Zoom accounts in PSU? Okay, great. Yeah. So, feel free to get together and debug stuff, coordinate on Slack or on the gaming thing that my kids use. Sorry, the Discord. Thank you. The Pokemon, whatever it is that you're using. Okay, awesome. Minecraft. Excellent. Thanks, room 1. Thanks, Claire. Room 2 was, let's see here. It's Al, Kira, Max, Matt, Ruchir, Junyi, Harsh, Ben, and Pragati. We can talk about some of your experiences with remote learning, what worked well, what didn't, and some any ideas that you have.
I can talk for us, I guess. We talked about some of the things that worked well are being like more flexibility with the attend anywhere model. So specifically the attend anywhere, where you can go to lectures if you can make it, but then if something comes up, like you get sick or childcare, that kind of things, and you can choose to attend remotely. I guess that goes hand in hand with the recorded lectures too. And then things that haven't worked well, I think, correct me if I'm wrong, guys, but our contribution was that it's harder to do group projects in some respects, or like at least to get them going in a remote setting. And I think my personal favorite idea for the course that came out of our discussion was the idea that maybe we could do some code reviewing of each other's code, where we get a chance to sort of like look at the different styles as we learn together and like review each other's code to get a better idea and get different perspectives.
Nice, I like that idea. We'll be doing pair programming, we'll be doing ensemble programming, mob programming, but that's all writing code from scratch. And I'll think on, we might have so now you mentioned it, there is an idea that we could explore for sort of looking at somebody else's code and working with it. So thanks, I'll keep that in the back of my mind. I like that idea. We'll have a chance to explore it. Yeah, thank you. Room 3, Shannon, Kristen, and Logan. What were some of your ideas for effective, ineffective things related to remote learning, and any ideas that you want to apply here?
I guess I could talk. So we all thought, flexibility with remote learning, like recorded lectures, no commutes, and being able to how PSU schedules a class, there's like 10 minutes between classes. So you could actually get to your class on time, if you're remote, instead of like running across campus, which is like not possible. So, and then like things that haven't worked. Somebody said, what was it? Oh, trying to gauge where you are in the class. Like, am I totally lost and everybody else knows what they're doing, type of thing. But like, are other people crying over their code, or is it just me, sort of thing. And then I think I put just an idea for class would be to stay caught up, because it's easy to get behind. So yeah.
All great advice. And, that's good. Thanks, Kristen. Room 4, John, Kaushambi, Rajat, and Deepika. What'd you come up with?
The biggest one, it was already mentioned, is just the ease of access to courses. Having the flexibility of times and recorded lectures makes it so courses where you wouldn't be able to take because it has a conflict with your job, you otherwise may have the ability to take. Things that don't work well can sometimes just be the like the medium of communication. If it's not well mastered within the course, it can be difficult to pick up concepts and actually interpret examples in a way that's meaningful.
Excellent. Cool. Let's see here. Room 6, Mandarin Shabati. Shatabdi, sorry.
Hello. I don't think anything was brought up that was unique compared to everything else that has been brought up by this point. Mostly just a lot of the same things, like recorded lectures, being a huge benefit. Probably really the best thing about remote, since it gives everyone access to it. I guess maybe one of the problems with remote lectures is people might start to try to rely on them instead of actually attending and then like actually asking questions, or like maybe they missed too many and now they have a backlog of like, especially for this course where it's a 4-hour class, where now they'll have a backlog of like 12 to 16 hours of lecture to go through. Though that said, I do enjoy for remote lectures being able to speed up the pace of the video. I personally like being able to watch things at like 1.25 or like 1.5 speed. I think that's nice.
Yeah, totally. 4.75 if I'm talking really fast. Excellent. Cool. And then room 7, Matthew Shrioshi and Rajashri.
We also thought the recorded lectures were nice. We also mentioned how it's hard to make connections and just do networking when we're remote. And then for ideas for the course, I think there were some people who were a bit concerned about how short the final exam time was, but we'll have to see how that works out. So.
It's 6 short answer questions. It's okay. Don't worry. It's like 22 years of people taking the final exam. It's all right. Awesome. Good deal. Oh, was a roommate? There was not. Excellent. Hey, thank you very much for going through all of this. I was looking at the ideas for the course. I think we talked a lot about these. A better class time. Yeah, right. Wednesday evening is not always the best, especially 4 hours of it. I work during the day. All right. You know, you can just, TiVo Felicity or whatever it is that you normally do on Wednesday night. What else have we got? Yeah, weekly screw-ups, recorded coding examples. Yeah, the lectures are full of those, so the stuff online. Encourage you to do all that. More time limit for quiz and final exam. Let me know what you think about the time limit on the quiz. Normally I don't have too much negative feedback on that, but hey, if it turns out that 20 minutes is enough for those 3 questions, let me know. Again, I want to do what's reasonable, and things change over time. Nice. Yeah, different class time. Sure. Cool. Great. Hey, thanks. Thanks for going through that, everybody. Really appreciate that. That's good input and food for thought for the rest of the course. Okay. Now let's dive. So before that activity, we went through and we created this student project. And the student project is it's what we'll be talking about in class, what we'll be doing here. And let's talk about what it is, what the student project is exactly. So it's called Project Zero here on the, I'm sorry, I'll just get Zoom, am I right? Okay, there we go. So many public windows. This is a project that actually way back in the beginning that I used to start getting everybody started, but I realized we use Project 1 for the same thing. So, but I still keep it around because it's a good example of writing Java code. So the whole idea is that we have this student class, and student extends human, which means that student is a human. So this is inheritance in Java object-oriented programming. And human is a class that you'll learn about in the I guess in the language lecture, in one of the Java language. I have this whole hierarchy of different types of animals. As a matter of fact, we can see that here. So in IntelliJ, if you hold down the Command key on Mac or Control on Windows and hover over something, you can then sort of dive into that. So if you want to learn about the human class, you can click on it, and this actually brings up the source code. The nice thing about Maven is that it will download the source code that I've published to the Maven repository, and so you can see it here in IntelliJ. So there's this whole hierarchy. As a matter of fact, wait a second, there is, I can show it to you this way, or I think somewhere there's a way to view the hierarchy. Oh, is it navigate hierarchy? Hierarchy. And we'll look at actions. This. Oh, type hierarchy. Nice. Okay. So again, this is what IDEs let you do. It's like, show me the class hierarchy for us, and there's an operation for doing that. As you can see, a student extends a human, which extends a mammal, which extends an animal, which extends an object. This is what IDEs can tell you, this kind of information right here. And so then, for instance, let's see here, all animals, I can navigate to that with F4. Oh, and by the way, I'm a big fan of using keyboard shortcuts, but I know when you're just starting to use a tool, you don't necessarily know what keyboard shortcuts are. And so I have this little plugin to IntelliJ that will pop up things. So like, for instance, when I hit F4, it pops this green bar at the bottom which says, oh, you just did jump to source. And it tells you what the keyboard shortcut is. So I hope that, I encourage you to learn the keyboard shortcuts because you'll be able to go faster. You'll have, be able to, have your fingers go as fast as your mind's going. But we're probably not there yet. So anyway.
How did you open up the actions menu to get this? Again, can you show that?
Yeah, right. So if I go back to student, yeah, it's probably a better way to navigate to it. But one of the things that you can do is do the search everywhere. And as a matter of fact, it's also over here, or you can also hit double shift on Mac. And this allows you actually, to search for really anything. You can search in classes. So I want to look for, for student. Oh, look, I can do here. Or a file, so like pom.xml. Oops. Pom.xml, I can look for pom.xml files. Symbols, like just name. That's probably a bad example. Probably a zillion of them. Like GPA. But find it. Well, not a great example for symbols. But what I just did here was actions. And so this is like an action that's performed inside the IDE. So I knew there was a way to get the hierarchy. So I just searched for hierarchy. And actually, I don't know what this thing is. I mean, it's the same thing over here as hierarchy. Yeah, so you can either hit the little magnifying glass, or I think it's shift. Yeah, we'll bring this up. And oh, look, here's like configuration options for showing the class hierarchy. You get type hierarchy. Oh, it's also Command H or Control H. Is that true? Close that, and then you say Control H for hierarchy. Oh, look, there it is. So, IDEs are really complex. There's lots of things you can do. I encourage you to just spend some time playing around and to learn about them.
Thank you.
Yeah, no problem. Okay. Where was I talking about? Oh, the hierarchy. Yes. So we've got the student class here, and the goal of this assignment is to implement this student class, and student has some information. The student's got a name, the classes that they're taking, the GPA that they have, and their gender. This is all attributes of a student. And then it has some behavior. It has some methods. So like all students say this class is too much work. There's a toString that describes the student, and the specification is a little bit below. And then there's a main method. So I think you've all worked with the command line before. And so remember maybe from C or C++, there's like a main function. It's got the argv and the argc. And actually, I don't know if they teach you that not or anything. But the whole idea is that this is the main entry point to your program. This is where everything starts. And you can pass in information on the command line. Java has the same thing. If you have a method that is public, static, and void called main, and it takes a string array of arguments, that's where the program starts. And what this program is meant to do is parse the command line as described below, and will print a description of a student to standard output by invoking its toString method. And so then this is some pretty straightforward functionality that when implemented will let you experiment and learn about how to parse the command line, how to store fields, information in the fields of an object, invoke the and implement some methods, things like that. And I don't want to go there right now, but we'll see how to run things from the command line. But actually, here is, I mean, we will. So the whole idea is that ultimately what we want is when you invoke this command. So a jar file, and we'll talk more about this next week. A jar file is a Java archive. Basically, when you compile all your code, you get this binary format called class files. You glom all those together, and you basically tar them, zip them up into what's called a jar file. And so now you have one file, which is an artifact which has all the code in your program. That's what you can share with other people. It's also what you run. And when you provide, so you run the Java program like this, and by the way, the backslash is the line separator on Unix, so it's all in one line. When you provide the arguments Dave, mail 3.64, algorithms, operating system in Java, it should print out the string, Dave has a GPA of 3.64, is taking 3 classes, algorithms, operating systems in Java. He says this class is too much work. This is the specification of the program. This is the kind of thing that you'll see for your own projects. We'll get to that in a little bit. But this is ultimately what we're doing in the student project. And we'll start this week, but over the next couple of weeks, we'll build out this project. I'll be doing the coding and you'll be watching me. And we'll learn about test-driven development. We'll learn about how to do some Java things, just to give you an idea of what it's all about. So that's what we're looking to do here, implement this simple student object. And the way we do that is with the student class. So here's all that code again. Now, I'm a big fan of test-driven development, meaning that before you write any main code, you write a test that expresses the intent of that code. And the reason that you do this is to ensure that you understand what your code is supposed to do. One of the things that I've learned, one of the lessons I've learned the hard way over the years is that I would write code before I really understood what it was supposed to do. I'd be like, oh yeah, right, it needs to do this, and so I should do that, and I end up writing all this code, and it's a mess, and it doesn't work. And so then again, towards working in small things, I focus on one little piece of functionality, and I say, okay, I want to just get that one piece of functionality working, and I want to validate it with other code, with test code. And by doing that, what I end up doing over time is I build up more and more functionality, and I have this whole suite of tests that I can run against it to make sure that it still works. So I'd like to start that now. So I've got the student class, which is the code that's under test, the code that I'm going to test. And the way I do, and now I want to have the test. Now the test itself is separate from the class being tested. This is called student test. So I'm going to split it off so I can see them side by side. So over here on the left, oh, actually I got the way, what? Here we go. Over here on the left, I have the student. This is the thing being tested. And over here, I have the test that I've written. Now, a unit test in Java is just more Java code. That's kind of nice. And so we've got a class here, which is our student test. And the naming convention is that you've got a class called student. You have a test called student test. Oh, bother. There we go. Out of the box, it comes with one test, and you know it's a test method because it has the @test annotation before it. And it says student named Pat is Pat. So I'm going to have a little code here that verifies that when I create a student whose name is Pat, that yes, indeed, when I call the getName method on that Pat student I created, that it is equal to name. So here on line 21, I create a new student, and then I use this assert method, and this is all explained in the JUnit lecture. This is from a library called Hampress that gives you a nice, what I think is a human-readable way of making assertion statements. It also gives you really nice error messages when things go wrong. Oh, by the way, sorry, an assert means that you are checking an assumption that you're making about how your code works. Right? And so you're basically saying, like, hey, listen, when I create a student that's named Pat, I assume that its name is actually Pat. This might seem simple, but this is the way you build a functionality. It's one little piece at a time. So here I have this code. And in IntelliJ, I can run it by clicking this green run test icon in the gutter. and I run it. And what IntelliJ will do is it'll build the project, compile all the software, and then it'll run this test. It's, takes a moment or two, especially the first time here. And it ran super fast, which is great. Fast running test is a great thing to have. And it said that, yes, in my student test, I had one test called student impact. Oh, there it is. And it's got a green check mark next to it. It means it passed. Great. So so when you write a test, again, if you're doing test-driven development, you write the test before you write the code being tested. So I'm going to go back to my program specification and look for sort of like the next simplest, most easy test that I could write. And when I look at the functionality here, yeah, there's all sorts of stuff about GPA and everything like that. But I'm going to use, I'm going to look at the says method instead. If I see a question has come in, why are we using var instead of student class? Well, because I can. So this is a language feature that was introduced a little while ago, where you can have a variable. The type of it is student, right? That's nice. But you know what? You don't always need to have the type there. So just as for the sake of demonstration, I just made that a var, meaning that the compiler will infer the type of that object. So yeah, probably most of the time I would have done student, but I don't know. I was apparently feeling like in a var mood when I wrote this, and so I just used that instead. That's it.
I have a follow-up question about that. I know in some other languages, like the way you declare a variable, I don't know, like JavaScript has like const, let, and var. It changes the scope or some other things. Does that have any unintended consequences?
No, the var keyword in Java is much simpler. It is just, yep, this is a variable. This is the inferred type of the variable. It's just to take it out. Sorry, like auto. It's inferred. Oh, what language is auto in C++? Okay, the question is, okay, if I have, that's a great question. I don't know, so let's find out. So let's see here. Can I assign Pat to a new animal? The animal might be abstract. A new cow? Yeah, cow is an animal. I probably need to import it or something? Yeah. And then I bet it has a name. Jesse. Okay, sorry. A cow is another type of mammal. It's not letting me do that because it's saying that the type of Pat is a student. So Java is a strongly typed language, and the typing happens at compile time. And so then really all var is a little bit of syntactic sugar to say that, yep, you don't need to specify the type of that variable. This would be really convenient. Java went through a phase, I'd say about like 10 or 15 years ago, where other languages, and whether it was Python or Ruby was really popular at the time, they're saying, our syntax is so much simpler, why do you have all that boilerplate, Java, bad, and a lot of that was justified. And so then, they took that feedback to heart and put in things like vars into the language. Now, in the hindsight, it hasn't like taken over the world or anything, but it's an option that we have.
Does the use of var here only work when you're also newing the type? So like var pat equals new student? Is that what inference works, I guess is what I'm asking?
I don't know. Var I equals 5? Yeah, you can do that. But yeah, you can. Var is only applicable when you're declaring a variable. So it's basically, hey, an inferred type of this variable.
So like if you went var Pat equals, and there was some other student you were assigning it to, it would do the inference. It'd say, okay, Pat is now going to be student Tim or something. Or, you know what I mean? Like,
yeah. Like this?
Yeah. Does that then make the inference that Tim is also a student?
Yep, it is.
Oh, cool.
And, okay, yeah. And so then like, Tim.getName. No, there's no performance impact because it's all compile time. So I bet if you look at the generated bytecode, it looks exactly the same as it would if you had declared that type. It's just, again, it makes it easier for the human to read it, has no impact on the computer. Yeah, good question though, so no performance of that. Wow, awesome, good deal. No one ever asked about VAR. Great, okay, so then, I want to test something else, just to show you a test, and we'll watch a video. I want to, I'm looking at this specification. I think the easiest thing to implement is probably the says method, right? So it's like, ooh, all students say this class is too much work. Well, how do I codify that? How do I validate that behavior in a test? So I will say I want another test method. So I'm going to have, a test. And by the way, like in IntelliJ, as I start typing something, it's like, oh, I start typing at, I say at, so this is an annotation. You can read about what annotations are. And then I start typing T, and it's like, oh, look, here are all the annotations that begin with TE. And then when I hit return or I hit tab, it'll fill in the rest. Nice. So now I can go real fast. Now, all test methods in JUnit are void. They don't return a value. They are of type void. And they need to have a name. Now, I have been criticized for having very long test names, but I want to err on the side of clarity. And so then I will say, all students say this class is too much work. Now, yeah, I mean, this might be laughable, but you know what it means, right? Yeah, so, and that's the thing, because, another lesson I've learned the hard way, having variables called X and I, or, why have value when you just have val? It's like, oh my gosh, seriously. You're not, you won't get paid anymore, and it's not like, we're trying to conserve room on punch cards anymore, right? This isn't 1960. And you're not gonna blow out your Git repository because your method names are too long. It's okay. It's way more effective to have names that are understandable, to take the time to express your meaning, because the next person who reads this will be able to understand it, and that next person is probably going to be you, right? So do yourself a favor by being expressive. Okay, so all students say this class is too much work. So now I'm going to create another student, and I'm going to call it student. Oh, thank you, IntelliJ. It's like telling me what I need to type. This is great. Okay, I'm going to create a new student, and oh, sorry, I just did parameter info, command P to tell me what all the parameters are. So name, I really don't care. Array list of string. An array list is a type that's basically like, like an array, but it's an object. 0.0, and it doesn't matter. So I have a student here, and now I want to do an assertion. I want to assert that, and I want to assert that when the student says something, what do they say? This class is too much work. Is that right? Yeah, that's too much work. Oh, that's all right, and I didn't get that right. I need to say equal to this class.
Does that do a deep check, or is it just shallow?
I'm sorry?
Does that do like a deep check? Like if you're passing like an object, for example, to the second parameter, does it check like all the properties?
Excellent question. So the answer is no, not unless the object itself does a deep compare. So one of the things that you'll learn about in the core API lecture is the equals method and what its semantics are. So every object in Java has a method called equals that compares itself. It's an instance method. So I'm comparing myself to some other object that's passed in the equals method. And it's up to the object object's class to say, how do I compare myself to another object? So if you were comparing two students, the equals method would probably be like, yep, we have the same name and have the same GPA, or you probably want a student ID if you're doing this for real. But the whole idea is that in Java, you have a shared mechanism because every object has one of these things. What the equal to method does is it will, really what the assert that does, technically it's equal to. uses that dot equals method to say, hey, is the string returned by says the same equal to this string right here? Does that answer your question?
Yeah, that was great. Thank you.
Yeah. Okay, so here's my test. Wait. Question from, yeah, do we override the equals method? You will override the equals method in project 3. So eventually you'll need to do it, but we're not going to do it here. Because, well, it's string, you don't need to, you can't override the string as final. But here we won't, but you'll see it in project 3. Okay, I've written a test, I create a student, doesn't really matter anything about the student, like the student's name or whatever, and when I call it says method, I expect it to equal this class is too much work. Now, if I run this test right now, what will happen?
I will fail because you didn't write says, right?
Yes, but you know what? Let's find out. Right? That's the nice thing about computers, right? You know, they're pretty forgiving. So let's run it and let's find out what happens. Okay, lots of red, bad. Okay, so what happens? Well, okay, so it prints out something called a Java-lang unsupported operation exception and saying not implemented yet. So okay, says isn't implemented. And then it gives me this stuff right here. It's called a stack trace. So the error, and you might have encountered this in Python, maybe in C++. In Java, when something goes wrong, the way that, something unexpected happens. Very wrong, it's unexpected. What happens is an exception is thrown. And the whole idea is, let's say you're doing something like indexing to an array, or divide by 0, or just like your program got some information that it doesn't like. The way you communicate that is via an exception. You don't have some weird return code. You don't set a global variable. Instead, you throw an exception. And an exception is a concept built into the language, therefore built into the runtime. And when an exception happens, what you get is this stack trace that shows you here's all the code that was executing when the exception happened, which is great for debugging, right? Because it tells you like exactly what line number was being executed and then what code called it. So then what it allows you to, and then IntelliJ, when that exception occurs, it is able to then let you navigate into those classes. So for instance here, on the tax trace, you had student test, all students say this class is too much work. You can click on 29. Oh yeah, right. Here it's when I call the says method, it's even underlined in red. And I think if you hover over it, yep, it'll tell you that, oh, this exception was thrown. This is so nice, right? And now here in the stack trace, you can look on, you can actually drill into the code that threw the exception. That sends you over to line 34 over here. Oh, and sure enough, our says method throws an unsupported operation exception, okay? That's cool. So we now have a failing test, and that is the first thing that you want to write, is a failing test. And now that it's failing, I want to make a pass. So how can we make this pass? We need to implement the functionality. How do we implement the functionality?
Do we return the string, this class is too much work?
Yeah. Okay, we've implemented it. Now we'll run our test again. It's gonna fail. Yeah, it's gonna fail. But I want to show you what happens when you have a failing test. So there was like it failed before because it wasn't implemented yet. Oh, I thought I implemented it correctly. Oh, but I didn't exactly. And what I want to show you here is this is what happens when an assertion. So instead of getting an exception when you were running your code under test, it ran okay, but it got a value it didn't expect. So, and this is a really cool thing that you get from this Hamcrest API, is that it basically tells you, hey, an assertion failed because I expected this string right here, this class is too much work, but I got this string, this class is too much work. I don't know. And you can do, and IntelliJ will like diff it for you, which for this example, I mean, it's like really easy to see. It's like, oh, look, you got an exclamation point. Well, let me tell you, when you are like diffing like a whole big piece of text, this is a really great thing to see. Anyway, yeah, you all caught it. You're smart people paying attention. I'm so glad. So now let's get rid of that exclamation point. And now it's green. Everything passes. So this is how you do test-driven development. Right, you write a test, and and you first start off by writing a test that you know will fail because you haven't implemented it yet. That's exactly the right thing to do. You see it fail. Actually, it's really important to see it fail. I've written so many tests. Well, actually, there was a time where I just write a test. I didn't bother to see if it failed or not. And it turns out that like there's a bug in my test. It was doing the wrong thing. And so it didn't matter what I implemented. It never worked. Or actually, it worked when it shouldn't have. And that was a bug on my part. So anyway.
I have a question. This is more like a vocab check on my end, but would it be fair to say that we're using the JUnit testing framework and that's using Hamcrest API for like those assertion methods?
Oh, excellent question. There's more details in the JUnit lecture, but to answer that question, you are using both, we are using both the JUnit framework and the Hamcrest library. The JUnit framework, we're using these @test annotations. That's part of JUnit. So the @test, if you look at the package up here, it's org JUnit Jupyter. You can learn about what Jupyter is in the lectures. But that's test. And so so IntelliJ knows that when it sees that @test annotation, this is a JUnit test, it'll run it using the JUnit framework. And so which basically goes through and looks at your class and says, every method that's annotated with @test, run that as a test. And then when it runs it as a test, it's just executing Java code. Not a lot of magic there. And assert that is part of the Hamcrest library. So both assert that and equal to are part of the Hamcrest library. And that's just Java code. But Java code that then is used as part of your test to make these assertions so that you can make sure that the code that you're testing behaves as expected. And when it doesn't behave as expected, you get nice error messages that are clear and easy to take action on.
Cool. I tend to drown in the jargon, so I try to get a jump on it before more comes at us. So thank you.
Thanks. Yeah, and there's going to be a lot of it. Just wait until we get to the servlets and get to the REST API stuff. There's a lot of tools, and that's just the reality of software engineering. Gosh, there is just so we just had like during my professional career, there's been this Cambrian explosion of like open source software. Like that's really what changed it. I mean, gosh, there was a lot of software like in the 80s, and then all of a sudden, when people realized that we should just put stuff out there for everybody to use, wow, there's so much. So yeah, I mean, part of being in this profession is learning how to navigate this very huge and often complex network of terminologies and techniques and libraries, and of course they're running out of names, and so then Kubernetes, what? It's like all this. Yeah, I get old, I guess. Anyway, all of the good names are taken, and so we have that kind of stuff. Excellent. So we have just written a test, and it's passing. And so let's celebrate by committing the code. And so then the way you do that in IntelliJ is that you go over to the commit tab here, and it tells you what's changed. Actually, we kind of saw the changes that we made. Notice that like when we added new code, we get this green bar over here in the gutter, and actually you can do things like, if you click on it, come on, there you go. You can revert, you can look at the diff and things like that. What's this changes? You can put it in a change list. And when you change code, you get a blue bar here in the gutter. And then we go over to the changes, when we go over to the commit tab, you can select the changes that you want to commit and just say added our first unit test. And you can either commit it to the GitHub repository. Oh, by the way, this commits it to Git, right? So it puts it under, adds the changes to source control. So you can either just commit it or you can commit it and push. I want to commit and push. So it goes and, it found a couple of warnings. This is a little linter it has. It's complaining about things like I'm not using this parameter. True, I will later, so I'll live with these. So I'll ignore the warnings. That's okay. And so I'll commit anyway and push. So it committed to the repository, the local repository. Now it's pushing it up to the origin, which is on GitHub. And so I'll push it. And there's status down here, and so it's pushed. And everything was committed. And so now when I go back to Now when I go back to my GitHub repository and I refresh, go back up to the top here, and our first unit test. Very nice, and as you can see, it's all there. Now, actually, one of the things I want to do is here from the command line, I want to run Maven verify just to make sure everything builds in Maven. Because ultimately, when I test your stuff, it's going to be running the Maven command line. I'm not going to have code open in IntelliJ. Nice. And okay, so that passed. And now what I want to do, this is my PSU machine. So I'm still logged into PSU over here, right? It's still valid. Now what I want to do is, well, I can do it from that directory, I guess. I want to do a git pull. So this code, actually, let's just take a look at our source test. So actually, let's main Java student. If we look at the says method, this version of the code still has it throwing an unsupported operation exception. So the code right here has unsupported operation exception. So I want to get those changes I committed to GitHub. No, sorry, I want to, yeah. And so I'll do a git pull. And what that does is it goes and gets the changes. It just sends over the deltas, which is the great thing about version control, right? So you have all of these sort of checkpoints along the way, and what it's really good at is just saying, well, here are the changes, go send the changes down. So you're not like moving all of the files. Now, of course, these repositories won't get that big, but like the ones that I deal with at work are huge, and even with fast networks and stuff, that would be a real pain. So this one just sends out the deltas, and notice it tells you the files that change, which is a good sanity check. I was like, oh, that's what I expect. And now when I look at the student, oh good, I've got the new implementation. It says that this class is too much work. I'm going to run Maven verify over here just to double check that it works on my PSU machine. It was running the tests, and actually you can see now that it was running 2 tests, which is good because I added the second test. So it looks like everything was going all right, and it was successful. Yay!
Can I ask kind of a silly Git question?
Only silly ones. It's not going to be silly. It's going to be a good question.
Maybe. Well, you just did a git pull, and I'm used to doing a git pull origin main. What are the differences?
Oh, git pull, the default remote repository is origin. Or if there's only one remote repository, it just uses that one. It's the same thing.
Oh, okay, okay. But you only use it when you only have the one default origin.
I think that's what, yeah. So either it defaults the name origin, or if there's only one remote repository, although, okay, sorry. Yeah, I guess when you, probably if there's only one for fetching, you use the origin.
Yeah, okay, that makes sense.
It wasn't silly at all. Branching is, it's not so much the branch as it is the origin, but yeah, branching is like a whole other thing, which you don't have to use in this class. I have to admit, Git is really great. I encourage you to stick to sort of like the vanilla Git workflows. I've had some students really shoot themselves in the foot by like, oh, reset my head, and oh, I saw this thing on Stack Overflow. Like, yeah, really? Dude, yeah. Git is hard, and there's a lot of advanced stuff. Version control is hard. It always has been. And while Git is a great tool, and it's so much better than everything else, especially for distributed. Anyway. But I guess like be careful. It's one of those things that I've learned the hard way, where it's unless you really know what you're doing and you really sort of like have a good mental model, you can really hurt yourself. So work in small increments and just use it for rolling back if you have to. Okay. So we just saw several things. We saw a little example of test-driven development where we wrote a little bit of, we wrote a test that failed, we made it pass, and then we committed it to GitHub. we were working on my local machine, so we pushed those changes up to GitHub, and then we pulled them down onto the PSU machine and ran them there. And those are the kind of things you're going to be doing, right? Now, you probably don't need to test it on PSU machine for every commit, but hey, you're going to be developing some stuff on your local machine. I encourage you to commit early and often, sort of as you get things to a stable point. And then at some point, you want to make sure it works on the PSU machine. So pull those changes down and do that. And because you're using GitHub, I think this is way easier than like copying files around, or I've seen a lot of students, even still now we have Git and GitHub, they're doing that, and they always end up they always make some mistake, or they blow away something, or things get into an inconsistent state and they want to run it and compile. So it's like, nope, I think Git is a really good tool to learn and to apply in this course. Nice. I think it's time for another break. Let's take 9 minutes and come back at 8:30, and then we'll do something else. I need to figure out what exactly. Okay, hey everybody, we're back. So let's see here. Let's review where we are tonight. So after talking about the syllabus and all that stuff, we finally dug into some code. We created a GitHub repository. We used a script to create that student project, and we just saw how to do some test-driven development. How to write a test that fails, make it pass, commit everything to GitHub, move the code around so that we can validate it both on our local machine and on the PSU machine. And that's some of the foundational stuff that you'll be doing in this course. And so I encourage you to go home and not only get your environment set up, but sort of go through some of those things, right? Maybe use the student program, or as we'll talk about shortly, break a little ground on your project one, just to make sure that you got all the pieces connected and that you can do that workflow. You don't want to get like all the way, you don't want to be right before you're ready to submit the project, only to find out that like you don't have all the GitHub stuff hooked up. So let's see here. It's 8:30. I think I got another hour. I got no more than 59 minutes left in me. I know that much. Let's talk about the first two assignments that we are of the course. So let's start with project one. How do I get rid of that thing? There you go. Nice. So this term, you'll be working on a 9:30, I thought. Does it say 9:10? I don't know. You all know. Okay. Okay, whatever. Okay, cool. 9:10. Twist my arm. Cool. So we're working. This is the first part of a 6-part project that we'll be building up over the term. And what we'll be doing is building in an airline application that models flights that go between different airports, happen at times, and everything like that. Eventually, you'll be doing much more interesting things like writing to files and making it pretty, and then have a REST API and Android application. But right now, this is just the first project. And the first project is to really just get your feet wet with a Java programming, making sure that your environment's all set up. So here in this project, you'll create your fundamental classes, your airline and your flight that you'll work with for the rest of the course. And really, it's to get you just used to doing some Java stuff. So so in this course, there's code that you write, but your code often extends my code. So this is an important part of programming, right? You have got someone else's code that you work with, and you need to extend it, and I want to give you experience with that. So I've got code that I've written called Abstract Airline, Abstract Flight, which provide the contract for the airline and the flight. It gives you a little bit of scaffolding to build from, and you need to build the rest. And also then you need to use the flight and the airline class in the program to do some easy stuff. And so then each airline has a name, and an airline consists of multiple flights. A flight departs from a source airport and leaves at a given departure time, and it arrives at a destination airport at a given arrival time. First assignment, all of this data, so the times and the airports and stuff, that's all going to be modeled with strings. We're going to keep it really easy. Don't worry, in future assignments, you'll be using things like the date class, and we'll have only certain airport letter codes that are allowed and things like that. But for right now, hey, let's just keep it easy, things like that. There's also a number for each flight, which is represented using an int. So an int is a 32-bit integer in Java. For this first assignment, you can ignore get departure and get arrival methods. Those use the date class. You'll see that in project 3. But for right now, you can just ignore them. They have return null or something like that anyway. Cool. So there are your airline and your flight classes, which represent things. There's also a Project 1 class. Now, Project 1 is a class that contains your main method. And the main method parses the command line. And what it should do is it should create an airline and add a flight to it. And the description of the airline and the flight are specified on the command line. Also, it can optionally print the description of a flight by invoking its toString method. So as we'll learn about in the lectures, toString is a built-in method, or is a method that every object has, which returns a string representation of it. This is like super convenient when you're debugging, or when you're just like, knowing that, hey, no matter what kind of object I have, whether it's a date or a database connection or a socket or a file, or I can call the toString method and get some information about it. And so then flight and I guess flight has a toString method that, do you need to implement it? No, I've implemented it for you, and you can't override it. I'm pretty sure I made it final. So when you run your program using java-jar target/airline -2020, put the jar file on there. You run the command line, and then on the command line, the arguments to the Java program. You can have some optional things. So you can have a -print or -readme. We'll learn about -readme next week. And then you can have the arguments. So the first argument following any optional options is the name of the airline, then the flight number, then the 3-letter code of the departure airport, the departure date and time, the 3-letter code of the arrival airport, the destination airport, and then the arrival time. So the whole idea is that you run the command line program and what the main method does is it takes the arguments that were passed in and then will create a flight with the flight information added to an airline that I just created, and then optionally print it out. To be clear, that's all it does. It doesn't save anything to a file. Project 1's kind of lame. It doesn't have a lot of functionality, and that's okay. Don't worry, there'll be plenty of functionality later. For Project 1, we're just, again, getting our feet wet, just learning how to do some stuff. A whole bunch of sort of footnotes about things, and that if you're working on the command line, multi-word arguments, like if you have a multi-word name of an airline, those go in double quotes, so it ends up being one command line argument to the program. Dates, however, have the following format. It should be month, day, year, and then in a separate command line argument, hour and minute, and it's 24 hours. So here's some examples there. So when you have like the departure time and the arrival time, this is what it looks like. And there's the year should always be 4 digits, but the month and the day can be expressed as either 1 or 2 digits. Now, one of the key objectives of this first assignment is to parse the command line. I don't know how much experience you have parsing the command line. It's a good thing to be able to just parse text in general. Everybody does it in their career. And just in general, like when the question came about, like, will you provide us with the test cases? No, I won't, because I want you to think about what can go wrong, right? And as part of being a software engineer is understanding enough about the problem space, not only understand the happy path, like when things go right, exactly what you're supposed to do, but also to behave reasonably when things go wrong. So when something goes wrong or something unexpected happens, the program should exit gracefully. So I have it down there in the footnotes. Gracefully means it should have an error message that makes sense to the user. It should not have a stack trace. You should catch your exceptions and print out a reasonable error message. Some examples of things that go wrong if your command line is missing something, or there are extra command line arguments, or if the format of the information on the command line is not correct. So the date time doesn't match the specification up above, the flight number is non-numeric, or an airport code doesn't contain 3 letters. As you're working on your assignment, if you are wondering, hey, is this particular input valid or not, ask me. Either send me directly, or feel free to ask it in the forum too. I'm not going to give I'm not worried about like giving away some secret combination. I'd much rather have everybody understand what the what the expectations are. Question? Yeah. Question. So, should my unit tests test for exceptions? Yes, it should. And maybe next time we'll see an example of that. And actually, that's a really okay. Now I want to like go into my whole spiel about that. I'll say yes. And so then again, we'll see that next time. Good question. And we'll also talk about the testing requirements, the automated testing, unit integration testing requirements next time also. Sweet. Note that when there are no command line arguments provided, the program should provide a helpful error message. So again, it's not just like not missing arguments. Tell them what the arguments are and how to use it. Submitting, we'll talk more about that in detail next time, but there's a whole section of the README and getting started that will explain that, so we'll go from there. And okay, so now that's the specification of the project. Before we dive into the code, any questions about what the project 1 is supposed to do? Nope. Okay, some more might come up. So there is a script called create first project in the getting started repository. So I'll go back to my getting started repository. Here I am on my local machine. I'll go up 1 level here at the top of the directory, and I'll run create first project. This is just like creating the student project. Now it's creating, it creates a new folder called Airline. So this is what has your Airline project. And you'll use this Airline project for projects 1, 2, 3, and 4. When we get to the REST API, we'll create a different project. And then Android will be another project. But we'll be using this for half the course. Airline, this is very familiar from student. It's got sort of basically the same stuff. Source main Java. It's got a couple more files. We'll walk through those shortly. And for project 1, you'll only need airline flight and the project 1. The XML helper, the text dumper, and text parser, we'll learn about those later on. So here is all of the code. Let's add that to GitHub while it's kind of in this clean state. Git status, we'll say git add pom.xml and airline. Well, actually, you know what? No, let's do it for IntelliJ. Yeah, let's do it for IntelliJ. Okay, so let's see here. So going back to IntelliJ. Now, remember, IntelliJ read those files that were there in the file system. And we can go back and look at the project. And we can see that IntelliJ knows about student, but doesn't know about airline yet. Well, that's fine, because we can, I'm just wondering if there's a shortcut, or there's not. You can go to File, and then you can say Reload All from Disk, which is like synchronizing what's there on disk. It'll go off and look at the file system. Oh, and now it's detected an airline directory. And how's it different from a git pull? Nothing's in git yet. So a git pull is really operating on the repository, not on the local file system. So the git pull, so there's the file system, which is like in the C drive, or there's the file system. That's one concept. There's the repository, which yes, are files there, but they're maintained in version control in the GitHub, in the Git repository. There's GitHub, which is a Git repository which is hosted remotely on the internet. And then you've got then you've got your local checkout, your local clone. Then you've got the clone on the PSU machine. So, which is also on a file system. So what I did was when I ran the script, that created files in the file system. And Git knows about them, but they're not under version control yet. So there's nothing to push yet because there are no changes to my repository. I haven't committed those local changes to my repository. Instead, and actually I'm about to do so. So, but I want to do so through IntelliJ because I just find that easier. So, okay, I synchronized, and what IntelliJ did is it noticed there was an airline file, a new airline directory, and it saw that there was a pom.xml, and it's like, aha, this is another Maven project. Okay, and it went and scanned it, and all of a sudden now airline is in bold because it recognizes that this is a Java project that has Java classes like airline and flight. So yay, IntelliJ, thank you for doing the right thing. But now if I look at Git, well, actually it popped up something that said external added files can be added to Git. And so you can say, great, whenever it detects an external file added to Git, you can do that if you want. I prefer not to. I like to do things manually and explicitly. So it's noticed that, oh, you've changed one file, and that's your pom.xml. I'm going to double click on this to see the diff. And what the diff is that it's added a module, a subproject for airline in addition to student. Okay, good to know. That makes sense. Then it has a bunch of unversioned files. And all of these, you can see they're in subdirectories. These are all of the files that were created when I ran the create project 1 script. All good stuff. I want all of this in Git. I want this all under version control. So I'm going to select all of these here in my commit. And now I'm going to say added files for the airline project. And I'll push it up to GitHub. So it's analyzing things. Static code analysis is really in vogue right now. And so IntelliJ wants to be helpful. Sorry, static code analysis, linters. So basically, looking at your source code to see if you've done things that are printed buggy or just smelly. It's nice. I use it a lot and advocate for it most of the time. When you're just getting started like this, it can be kind of annoying. Okay, so we've committed the changes to GitHub. This is cool. Committed the change to Git, push it to GitHub. And so then we can look at the class. Like here's the airline class. It extends abstract airline of flights. So if you look at abstract airline, it has this generic type T. You'll learn about that in the lectures, which basically allows the airline class to contain your own flights. And this allows you to have what are called generified, or rather use a generic collection that is strongly typed to your flight. This avoids some typecasting and makes your program overall safer. And it's something that you will explore as part of the project. Note that this class overrides functionality inherited from abstract flight, but it doesn't provide a decent implementation, right? They just throw this unsupported operation exception. Clearly, your job is to do the right thing when you, for your add flight method. So what you get out of the box is a project that contains, I guess, all the code that you need. Now I think about it. It contains your airline class, your flight class. Again, you'll need to implement these unsupported operation methods. I'm gonna, I'll just see the whole thing. Has a bunch of stuff that you need to implement. And then there's your project 1, which has your main class, which is your main class, sorry. And it's got a main method. And right now, it's just kind of got some silly stuff. What it does is it creates a new flight just to make sure that you can create a new flight. And then it prints some stuff to standard error, like missing command line arguments, and it just prints everything that was passed in the command line. And this is so as a demonstration for, and I'll demonstrate how that works. So I mentioned here in the assignment that you run the project using this java-jar command, and we'll do that right now. First thing that we need to do is go into our airline, and we're going to run Maven verify just to make sure that everything builds. So what Maven verify does is it compiles all the source code, all your main source code, so things like airline and flight and project. It then runs your unit tests, and by the way, there are unit tests here in this test directory for all of that stuff. So like here's a test for flight, and maybe we should talk about this stuff briefly. And then there's integration tests, which we'll talk about next week. So this was successful. That's great. So now we can run the main program by saying java-jar target. Target is the directory where Maven puts all the built artifacts, puts it all in one directory, so it's really easy to clean up. You just delete the one target directory, and then all of your intermediate files, all of your compiled bytecode, all of your jar files, all the things that get built from the source get blown away really easily. It also makes it, and also you can exclude those built, usually binary artifacts from version control really easily by just telling your version control system, you go to a target directory. Anyway, that's why they do that. And then there's your airline.jar. And so if we run this, it prints out missing command line arguments. We just ran a Java program. And if we then go to our project one, the reason it prints it out is because of that code right there, missing command line arguments. So similarly, if we say missing command, if we just print out, you give it the arguments 1, 2, 3, 4, it prints out missing command line arguments 1, 2, 3, 4 on their own line, because that's exactly what it does, right? It iterates over the array of arguments. Those are the arguments that are passed in from the command line and prints them out one on a line. So that's your main, it's your project one main class. You need to then implement the functionality described here where you parse the command line arguments that come in, and if one of the options is -print, create, rather, parse the command line arguments, create an airline, create a flight, add the flight to the airline, and if -print is there, print the two-string value of that flight. I encourage you also to take a look at the unit tests. I don't think I have time to go through that tonight, unfortunately. Actually, you had asked about how we test that and that an exception is thrown. This is exactly how you do that. So right now, I have a test that just demonstrates how you can validate that, yes, when I call the getArrivalString method, that an exception is thrown. And actually next week we'll see things like on the student programs, like, hey, what if I provide a GPA that's not a double, right? You want to throw an exception, like in that case, how do I test that? And we'll be seeing how to do that here too. Okay. Yeah, we're good. So we can share some of the command line tools you're using to quickly autofill and search your directories in the PSU Linux server. Seems like you are super fast and not typing things out. Oh, okay, yes. Sorry. One of the things that I'm doing, I have, I'm using Bash, and I have it in Emacs shortcut mode. And so when I do Control-R, I search up in the command history. So if I say Control-R verify, it searches for Maven verify. Max, is that what you were asking about? Those kinds of command line tools? Yeah. So, yeah, sorry. And here I don't have like the little pop-up like you do in IntelliJ. Force habit. So yeah, so I mean, this is Unix command line stuff, right? So what else did I use? And then again, Emacs mode. So if you're an Emacs user, you know Control-A brings you to the beginning of the line. You know Control-E brings you to the end of the line. You know that Control-B goes back and Control-F goes forward, and Alt-B goes backward, and Alt-F goes forward a word. I encourage you. Well, so is it necessary for this class? No. But like one of those things, like maybe in between terms, or if you just want to learn to be good at Unix, go learn to be good at Unix. It makes you, what I found is that it wasn't until like I learned how to do this stuff by seeing other people doing it. It's not like I'm like, oh, I should go get a book on Emacs. No, it's like I saw somebody do this, like, you're really fast. Can you teach me? Because I wanted to be fast too. Because like one of the things that when I was starting to be, you know, I was like when I was still in college, I realized that like the ideas, I didn't know enough to get the ideas out of my head quickly. And like when I found these tools, like something like that with VI, where all of a sudden it's like, oh my gosh, you know, they feel like they can go so much faster because they just have the things at their fingertips. And IntelliJ is the same way for me. We'll see more of a one, you know, once you, as I demonstrate test-driven development, as we start writing code and things like that, part of what what the lesson is how to use a tool. Nothing wrong with learning to use your tools. They're there to help. Right? It's like, you know, just like when you're in your woodworking shop and, you know, you're using the saw, you know, would you rather use a table saw or a hand saw? Sometimes when you have to use a hand saw, it's the right tool for the job, but when you're doing big things, you want to use the table saw. So you got to learn how to use the table saw safely. Okay. Let's see here. Okay, it seems like you did something that had a text edit mode or something. I'll look into that. I don't remember what I did. It was probably less. It was over here when I was looking at it. Okay, so the less command is, okay, so there's the old school more command, which has been on Unix forever, which the whole idea is that you've got a text file, actually you've got any file, and you want to display it to the terminal. The successor to that was called less, and so when you then give it a file path, and you probably also saw me do source, and then we hit tab, it does a complete. And so it's like, oh great, you know, it looks in the current directory and there is only one file that begins with SR, and so I hit tab, which is like, you must mean source. Hey, right? Okay, and then if I hit tab again, it'll show me what's in the directory, and then I can do main, and then, oh look, there's only one directory in this, so I can just tab all the way through. So yeah, that's what I was doing. Thank you so much for asking that. Was that actually who asked that? Yes. I've been doing this so long that it's just second nature to me, and I often forget that. I'll put this nicely. You probably haven't seen this demonstrated to you before in your classes, and these are the things that I wish I had known, right? You know, the things that it wasn't until I got to graduate school and then when I started working, or I was just around people that like knew these things and had been doing it for so long, and so then. Thank you for asking. Nice. Yes, tab completion is great, and as a matter of fact, one of the things that I often end up sort of like when we have like office hours or whatever. It's something that I encourage my students to use because yes, having to type everything is painful. Anyway, make it easy. Life's hard enough. Software is hard enough. Like let the computers do the heavy work. That's why we love them so much. Okay. What else here? I think I need to go talk about the Koans next. Okay, excellent. That is project one. Project one is due in 2 weeks. So again, I encourage you at least between now and the weekend, by Sunday night. Run the create project one, create first project script. Make sure all of that's working. Make sure that you can do a Maven verify, and that IntelliJ is working. At least do that much. Next week. Yep. And if you want to get started on plan of attacks, there is the how to document your projects handout. You can read it over, but we'll talk about it next week. Okay. Java Koans. Or Koan. So I'm going to kind of breeze through this here. I think everybody has some experience with the Java language, but there's stuff in the Java language you probably haven't experienced before. And while there's the lectures and stuff, there's no substitute for actually working with the code to learn how to use the language. And several years ago, I came across this GitHub repository, which has this little framework for teaching people about the Java programming language, these little itsy bitsy things. And I'm like, that's cool. Hey, can I use it in my class? And the guy, Matty B, was like, yeah, sure. He's a super cool guy. And so what I did is I forked his repository. I put some Maven stuff around it so we can really use easily in this course. And we get the Java Koans. So just like with creating the student or with project 1, there is a create Koans project script that goes and creates a new project for these Koans. Cool. I will quick do the refresh in IntelliJ and get that stuff into GitHub. So we can work with them. And the whole idea here is that you work through a series of various, I mean, literally small. It's like, here's like 2 lines of code and you fill in the blank. It's kind of like a Mad Lib almost, where it's like, okay, we're going to be learning about integers. We're going to be learning about objects. Let's see here. Where's the thing?
I'm pretty sure you did the
PSU in PSU, didn't I? Thank you. You are absolutely correct. I did that. I added in PSU. No problem there. We'll just go the other way. Git add Koans. Git status. Great. Git commit. Push. Oh, cool. The Git push failed because I had pushed some stuff up to GitHub that I hadn't pulled down into the local repository yet. So I need to do a Git pull. Got all that stuff. Okay. Sure. I like merge. Huh. I don't remember doing that before. Okay. So I punch it in. Oh, good. Fine. Okay, actually, this is a good example. Okay, here's what I've done. I have 2 copies of my repository. I made some changes on my local machine and pushed them to GitHub. I made some changes on PSU without getting those other changes first. Now I've made some changes and I want to push them to GitHub, but it's like, whoa, wait a second. You've changed that pom.xml file in a way that I can't reconcile. I need to reconcile it. Okay, which is actually exactly what we want version control to do. It's really great, but I've only got 9 minutes left. So, conflict. Okay, fine. I'll open up Emacs and I'll look at my pom.xml. When there is a conflict, oh, look at that. Emacs has colors and everything like that. When there is a conflict in code in GitHub, you get this these arrows and the equal sign and everything like that. And it's telling you that, hey, what is in your local repository is Koans. What came from GitHub, the remote repository, is Airline. The same line of code changed in 2 different commits. GitHub's like, I don't know what you meant to do here. You got to tell me. And that's good. And as it turns out, what I want to do is I want to keep them both. So I'll just delete all of this arrow stuff. This is what I want. Sorry, and I just saved those changes. And so then this is happier now. Oh, is there a git resolve? What do I need to do? Is it happy? Great. And so now it's happy. Good. Now I was able to push it up. Okay. But and I wanted both of those because I had added both projects. Now here in IntelliJ, it's almost like I planned it this way. I did not. I'm not that good. I can say update project, which will pull, or I can say pull, but update project sort of does what you want. This will now pull down those changes, and it'll say, you want to merge them into the current branch? Yes, please. I don't like rebasing. I always screw things up when I rebase. There are drums. Are those inside or outside? What? No, yeah, I hear the drums too. This is not a protest or anything like that. So anyway, yeah. Huh. Anyway, okay. So if I'm this thing underlined in red. Oh, it is like a palm. Okay, I'll fix that later. So okay, I pulled down changes from GitHub. And IntelliJ is like, it looks at those changes like, wait, you've got this new Koans project now. Poof, it gives you this Koans project. Okay, so I've got this Koans project here, and now it appears here on my local file system. I've got Koans. So let's go back to the assignment. I've created it. And the way the Koans work is that there's this Java program that runs, and it will, and it looks at these. I think I won't try to explain it to you. I'll just show you. So if you run this maven w exec java command, this actually runs a Java program with Maven. This is a fine thing to do. And this Java program, what it does is it prompts you to do some things. So it clears your screen, and it gives you this whole big block of text that tells you what to do, how to interact with these Koans. And so it says, hey, there's this file called about Koans, and there's a method starting with @Koan called find about Koans file. Look within it for your first lesson. Once you have solved that, save the file and check back here for your next lesson. Okay? Now I'm going to do this in IntelliJ. And I want to find, I want to find about Koans.java. And the way I do that is, yeah, I suppose I could look through all of this to find it. But, you know, we were looking at that, that find anywhere. You can say navigate to class or Command O on, or file. Let's do class. And it was about Koans. Okay? And this brings you to the source code. And let's see here. What did it say? It said there should be a method starting with @Koan called find about Koans file. Oh, there it is. Find about Koans file. And okay, it's saying fail with the message delete this line to advance. Well, what should we do? Good line. Yeah. Now I go back to my Koans. It noticed the change, and now there's a different text. And so it explains to you what you should do with the Koans. And so these are like little unit tests almost, right? We've got a little snippet of code that teaches you something. And this first one is really all about is all about just like the mechanics of these Koans. So let's look at the second one on line 15. And actually, sorry, I keep going back and forth here. Okay, it's telling you line 18 may offer a clue as how to progress. Now make haste. Okay. So line 18 here is failing here. What if Koan's complete variable is true? Let's make it so. True. Okay. Yep, it noticed the change, and now it's in a different a Koan class with a different method. Okay, well, let's go find that. About assertions. Okay, I will use my navigate to class, Command O, about assertions. Okay, cool. Okay, assert Boolean true. So just like we saw assert equals in JUnit or in Hamcrest, the Koans have this assert true, and again, this is kind of like Mad Libs. They have these like two underbars, and you're supposed to replace this with something that will make the Koan pass. So true or false? What should it be then?
True.
True. Okay. Nice. Okay, now assert Boolean false method. Assert false. Replace that with false. Okay. Good deal. Now, these first ones are pretty silly, but this is the pattern that you follow, right? So assert null object. What do you think goes there? Null. And this is its way of teaching you about these language concepts, like true and false and null. Now, you've seen the language before, so you sort of knew what this was. But, you know, as actually, if you go and look at all of the things, you'll eventually learn about enums and equality and exceptions. The Koans get more challenging, but this is a great way to learn the language in these little bitty pieces, right? Okay, so let's look at this next one. We'll just do the rest of the ones in this and then we'll be done. Assert null object reference. So, okay, we have some variable here and we assert null. So what should we fill in for this value right here? No, yeah. Okay, and then we'll go check it out. Oh, it didn't like something. Can I? Oh, yeah, okay, right. Thank you. Actually, if I had listened to or I'd seen IntelliJ, it would have told me. Okay. Oops. It's reading again. Sorry, I scrolled past it. Sorry, there we go. Okay. All right. Expected something other than null, but was null for, where are we at? We are, oh, there we go. Assert not null. Okay. What is something that's not null? Tell me what to type.
24.
24? 24, we'll go with 24. That's a much better answer. Okay, cool, everything compiles this time. Let's see if that works. Yeah, and you can tell because this counter right here is increasing. So we're at number 7 of 269. So this assignment is due like in 4 weeks. When is this one due? February 15th. Okay, got them. Boy, they don't have that much time in the summer. Basically, you know, what you do is you go through all these little things. Like here's, okay, a whole bunch of like arithmetic, right? You know what the answer is, but you know, you can, this is how you can explore. Because don't worry, it gets a little bit more interesting when you, there's about numbers probably. Where's the number one? Well, maybe that isn't begin, that might be advanced. But like bitwise operations, oh, there you go. Arithmetic operators, simple operators, not so simple, right? All of the, you know, what happens when you have a prefix minus minus versus a postfix minus minus, all this kind of stuff. You know, the intent here is that, so, you know, in your projects, you're using the Java language, but for a long time, I didn't have a way of sort of learning the Java language and all this stuff about, you know, more intermediate stuff with like Java 8, you know, Lambda functions and inner classes and more advanced stuff. I found this is a really great way to explore all of these aspects of the Java language in little isolated things that you can then apply in your projects and in the other code that you write. So let's commit that here. I started working on things. And so this is another thing I recommend that you get started on. Yeah, I mean, there's a lot of them. There's whatever it was, 269. But either a little each day, or you say, great, you know, hey, you know, Thursday night's going to be code night or whatever, and you do a bunch. You know, it is something where, you know, the goal here isn't to, yeah, you want to get them all done, but you don't want to like rush through them, right? This is something where you're meant to explore maybe the nuance of what you're seeing. Because, you know, I have to admit, a lot of them, you know, hey, yeah, you can just look at, you know, what the answer was supposed to be, and you can just fill it in that way. And I'm sure we'll do that every term. You're missing some learning out of that, because yeah, it's you know, it's pretty easy to bang through all of these, but you know, things about like you know, multiple inheritance or regular expressions, these are things that you'll want to be using in your, you know, in your career, and so then, you know, it's good to figure out how to use it. Okay. Russell, everybody's trying to get home. I don't blame you. I want to get home too. So that's everything. So you got those 2 assignments. Please start on them soon. In the meantime, yep, get on Slack, check out Canvas. Make sure you get all the GitHub stuff and everything like that. Reach out to me and to the class if you have questions or encounter issues that you want to explore. Thank you very much. I hope to see you all next week. Oh, and if you're not registered for the course, reach out to me too, and I will get you fully registered. Bye now.
Thank you.
Yep.